Chris, you online?
I am, yeah. I am.
Ah, where are you?
Muted.
yet. We're not likely to be there in short order on this. That's a much more difficult task, but we're hoping to get there within about a year on that. The fourth one was looking at the legal biomass in each regulatory area in each year. This was again looking at Objective 5, and then looking at bycatch from each regulatory area. We also looked at things like average size of fish in the population and in the catch as a performance metric, as well as the average number of years with and the duration of fishery reductions or closures. So this is the average annual variability in those metrics. Go ahead. Just to go back to some of the management procedures we were looking at here. We're looking at size limits, at catch limits, at rate of change of the catch limits, at the reference points that we're using. This is based on the harvest policy, as well as looking at the underlying harvest rates and the control rules that we use when we hit some of those reference points. And then the last part is this is looking at bycatch and wastage limits as well. So all of those are management procedures that we might want to look at in terms of managing this fishery and getting to the objectives that you have identified in this. So what I wanted to do here was to move on to what has been the experience of the members with the existing simulation tool and how this may have affected your ideas about what the management objectives for this fisheries might be based on both your discussions with others as well as your, as I said, the experience when using the Shiny tool on this. So I'd like to go around the table here and get some feedback from people on what their experience has been working with the simulation tool, if you have, and also the dialogue you've had with some of your colleagues in terms of refining what some of our management objectives might be here, or if people are satisfied with what we got, or we want to examine some other ones. So I'm going to go this way this time and start with you, Per.
Talking to my colleagues and stuff, especially in the Vessel Owners Association, it's mainly a wait-and-see attitude. They are interested in the size limits, looking at the 30-inch size limit. And you especially get a feeling from biologists how that might affect the fishery.
What was it? I just missed
that. They were looking at, there was some feedback on looking at 30-inch size limit for the legal size, and see what ramifications that would have on the fishery. And other than that, there was mainly a wait-and-see attitude. There's been discussion on pots, as we're well aware, as a harvesting tool or harvesting alternative, and with rather mixed feelings there. That's about it.
Okay. Okay. John.
I have to confess, relative to Steve's tool, I'd probably have a better chance of seeing him as a hockey player. The simulation, I guess, just not my kind of thing. But I confess, I have not used the tool that was made available. The issues, and I have to confess too, I'd get a D or an E if this were a graded course because I haven't done my homework. But the issues I continue to hear about, I have to say, and maybe it's not part of this discussion, first of all, let me say I think this is different than what I expected because I thought we'd talk more about the biology of the resource, and we're really talking about simulations and these kinds of generations of what-if things, and that's really a way of getting to, what choices do we want to make, and understand that, and so that it's different than what I expected. I guess I'd say the things I continue to hear about, you'll be surprised at this, the area-wide assessment versus the area-specific assessment. And being only the second person to speak, I hate to bring that up because there are a lot of other people I'm sure that's near and dear to. And I got to confess, the other thing I hear about is a lot, because I just spent some time in Southeast Alaska. I hear about, what's going on with 3A, 3B relative to that resource versus 2C, where people continue to tell me that, hey, our CPUEs are up, looks like our resource is in good shape, we're catching 40% of the fish we're catching are 2040s and 20% are 40 ups, or maybe it's more like 25, but whatever it is. But it looks like the health of the resource is much better. But I do confess I haven't spent any time with the tool, and again, if this were a graded project, I'd probably have to take it over again. Yeah. I'm ready.
Okay, thank you, John.
Well, I have to confess I did spend some time with the tool, and maybe too much. I don't know. It was interesting to see some of the results. Some of them were really predictable, I thought, but there were a few sort of counterintuitive or non-intuitive things that I puzzled over. But it was hard to really invest a lot of thought in it, knowing that it wasn't even necessarily a halibut. It was just an exercise to understand the trade-offs and all that. So I didn't take it much beyond that. In terms of feedback from constituents, most of them are way more preoccupied with the upcoming season and restrictions than the MSAB. So I don't really have anything new on that front.
Thanks, Scott.
I did get a chance to play around with the tool a little bit, and the one thing I really enjoyed is you could see what your management choices were going to mean in the long run and what different effects it would have based on what choices you made on the outcome of the population. I understand this is really rough, and we're hesitantly optimistic that as more and more information is thrown into the tool, we'll get a better idea of things. One thing that I keep hearing from everyone I talk to is they're really curious to see what variable harvest rates in different regulatory areas would look like in the long term. I hear from Area 2A from the tribal fishermen that they feel that they can sustain a higher catch rate than other areas. And they'd like to see what that looks like in a model played out and how that would affect the overall stock. And again, another thing that they always are really well behind, and I'm glad we put that as one of our first priorities, is to protect the overall stock. I mean, that's their bottom line right there.
Before you get to Michelle, did you have any thoughts on modification of the objectives, Scott, as a result of your playing, either one of you Scots who played with the shiny tool?
No, I don't think so, not at this time. I could change my mind later, but...
If I could just jump in there before Michelle starts. I guess I had a question about the management procedures. Those are still open for ideas, right? Yeah. Okay.
And I don't have much to add. I didn't play with the simulations, but did get a chance to discuss the 5 objectives with other folks in 2A and the other management agencies, and we all had consensus that those were the right ones, and conservation should be the highest priority as it is.
Yeah, I looked at that tool briefly and played with it for a couple of days, and it's interesting. It's cool. It's pretty shiny. And but until there's real data there, I don't really have that much interest in playing additionally. But I'm excited to see what you've got to show us so far, Steve. With regard to the objectives, there were a couple concerns. One was whether these objectives, these working objectives, deal with each area individually, or are they dealing with an area coastwide? For example, when you say that, that the removals can only change by 15% in a year, are you talking about, a coastwide, or are you talking, would that be true for each individual area? Because it might be very complex to have it apply to every area. How many areas have we got? About 8? I mean, are we creating an 8-headed monster if we have that a particular objective apply to each area? And my other concern with that rule is that, is 15% too high in the case where you have to make drastic cuts? But then I thought too, I mean, this is just a procedure, and commissioners can always alter, I guess, from whatever any tool tells them. So there's always an out, I guess, to if
the idea is to use the management strategy evaluation tool to find out would 15% satisfy the objectives, or maybe it should be 20%, or maybe it should be 30%, or maybe it should be asymmetric, go up by 30%, go down by 15%, or however you want to do it.
Right.
The idea is to tune the procedure to match the performance objectives.
So
and that's essentially
yeah, so
what
that's
we
just
got
a
to.
sample percentage that's thrown in there, I guess. Yeah. Okay. Yeah.
Gary, I guess the other part of that is that the area specific versus coastwide is partially dependent on the ability of tools for us to look at some of these things. So there's no question that the area specific is where we want to go in the longer term. We just don't have the correct tool for it right now.
Yeah, thanks. Similar to Gary said, is I think I really like those type of tools that help you illustrate, to show what your objectives or whatever you're trying to do, and you can kind of graph it, and it makes it really easy to grasp. But it's really it's a good, powerful tool to have. But until it becomes populated with sort of halibut data, you're not going to take it too much further. And similar to other people, there's some clarification on some of the objectives that are laid out there now, just what exactly they're meaning, and I think sort of a broader discussion later on. But that's what I can say for now.
I'm afraid to say too much about that model of Stevens because I might get labeled like Chris Sporer did last time. But I do know that you shouldn't have preconceived notions of what you think it might come out with. The one objective that we talked about last time was not having the fishery close in any given year. And I haven't played around with the model for a couple months, but I recall being surprised by what would happen under certain scenarios by not closing it. You could actually do damage in the long term. So that kind of surprised me. So I think that's a lesson that you shouldn't be fixated on an idea that you think is correct. You have to keep an open mind to study the data. And I would wonder, not being a scientist, if there's some redundancies in some of our objectives. And so if you're going to give us a review today, I sometimes get a little confused or wonder if for example, the minimum number of females, to get more. I think the original number that somebody came up with was 1 million. And I wonder what the point of that was, rather than just a minimum number. And as for the constituents that I talk to, or my fishermen, I would say one thing that they seem to be focused on in BC specifically is how wonderful the fishing is. And they have the biggest thing that they talk about is the bycatch and waste of fish. I would think that is probably the pet peeve of most BC fishermen is they feel that BC is sort of the baby getting thrown out with the bathwater, so to speak. And again, I'm not going to draw a conclusion about that, but that any fisherman will always mention that to me is excessive bycatch and wastage in our fishery.
When you say bycatch,
and I don't mean in BC, sorry.
Just
to be clear.
Okay.
Yeah, thanks, Bruce. These are basically opening comments, and by the time it gets halfway around, I'm almost starting to repeat some of the earlier ones. But on the simulation tool, I haven't really touched it since we had our meeting back in October, and it's probably the same reason for Gary. I'd be more interested in playing with it when it's populated by real data. And so, I think the tool was really interesting that we had last time that you put together, Steve, to look at these various implications of choosing different scenarios in management procedures. Thinking about the objectives themselves, I think I still would like to go back and have a review of the objectives. I kind of think that there's probably still too many of them. Nine objectives to me seems like more than we need by at least 4, for example. And I think we probably do need to fine-tune them, the actual wording of them. Brad gave an example about the minimum population size, and I guess another comment I would have about that one in particular is I think it may be redundant with some of the other ones, 2 and 3, for example. As far as scenarios and management procedures, certainly have some ideas on it, and that would be useful, I think, when we have some time to get into some of those ones and provide you a more fulsome report of what we're thinking about. Thanks.
Would you see that, Paul, waiting until you've had some more experience with the coastwide operating model and real data?
No, I think to me it would be useful at this meeting to spend some time on the objectives themselves and have another go through of them. And similarly, I think it would be very useful, and I think it's on your agenda already on it, Bruce, is, what do we want to see as possible scenarios, and what are some of our concerns around management procedures? For example, Brad talked about bycatch, and I guess I'd put it on the table as well as around bycatch mitigation. And so, another is a variable harvest rate strategy. Does it need to be the same in all areas? It'd be useful to explore it across a different one as well. And do we need the same harvest strategies within all areas? Now, so just some of the ideas that I've been thinking about.
Yeah, some of those, as I said, might be a little longer term till we can get the kind of tools we need to examine those things on an area-specific basis. But yeah, that's certainly in the right direction, Paul. Yeah.
Hello. As a new commissioner, the truth of the matter is I'm not really up to speed on a lot of this technical work that's being done on this level. I'm here to rectify that, and I appreciate the discussion that's going around the table here. Thank you.
I'll pass, thank you. Adam, do you want to speak? Is that close enough? Can I still be heard? Oh, thank God. Actually, I don't know if I have a whole lot more to say other than reiterate what some of the other folks from the Canadian side had said. Playing with the tool has been useful, but I think we got a lot out of it, or we got out of it what we could have shortly after the last meeting. Now we're really looking forward to looking at the new operating model, trying some actual data, seeing what it would look like. But I think more importantly for this meeting is to maybe try and focus in on a few objectives, discuss alternative management procedures and some scenarios so that the playing with the tool can be more informative.
I have not really had any time to play with the tool, but I haven't had ample opportunity to talk to various fishermen, and I've actually went out and observed on boats and had a lot of positive feedback on what guys are seeing, and I'm not sure how it relates to what we're doing here, but it is the same questions as John said. We hear a lot of the same things, area specific versus coastwide, potential for higher harvest rates in 2C. I think guys are overly confused on the relation of something that happens in 3B or Area 4 and how it relates to 2C. I think guys get confused and don't understand the process as a whole. And so when a guy sees increased fishing year after year, he doesn't understand how that relates to catch limits. And I just try and explain to him that it is a process and there's more than what's going on in 2C. There's a bigger picture, and I think that's a bridge that I have to continue to work on.
I played with the tool a little bit and took it back to St. Paul, and a couple of my fishermen friends tried it and played around with it. But I think, like others, be a lot more fun to play with once we get the halibut data put in there. And so what we were hearing from our constituents back in the Bering Sea is that they'd like to look at a reduction in the minimum size limit. And then one of the things we've been talking about a lot lately is incorporation of abundance indices of juvenile halibut in the model so that we can forecast recruitment. And we think if we can somehow include that in this new operating model and really see what the recruitments are looking like and be able to track those better would really give us a better picture and help us with our path forward. And then the last thing, I think like most people around the table, is we'd like to continue to look at lowering PSC caps and anything that will reduce bycatch.
I played around with the tool as well, and I thought it was helpful. Looking at the what happens over the time period in the worm plots was, I guess, an initial kind of qualitative way of seeing what happens over time. But then I thought that the tables for the different management procedures were really helped me focus in on some of them better. And I was thinking about the different procedures relative to our fishery objectives, and it occurred to me that I wonder whether the group here and other stakeholders would be interested in adopting a more conservative approach than the 30-20 that's currently in place, without knowing a lot better what the uncertainty is about the effects of bycatch and the risk associated with it. I think that's one of the main parameters of the tool that would suggest or assume that bycatch has a significant effect on, or could have, on what's available for catch in the biomass. So it occurs to me that until we have a better idea of what those amounts are and what the effects are on stock and exploitable biomass, that there's going to be a reluctance to adopt something more conservative in a management procedure. And then I really went off the deep end and started to think more about the management strategy evaluation process generally, and because what we have, and again I'm thinking about bycatch, what I didn't see any in the literature that you provided an example where there are really multiple management authorities that are responsible for the stock, for a stock, and so that wasn't the case for BC black cod. So currently for our biological management objectives are focused solely on spawning biomass, and I wondered whether there should be an additional objective, and at the risk of adding more, of maintaining U32 portion of biomass at a certain level, because that's what we're concerned about when everybody wants to reduce bycatch. That's primarily, and wastage, it's primarily U32 fish. So even though it's not the authority of the IPHC, unless I throw that question out. Is it appropriate to have or consider as a biological objective as a floor or some amount of U32 portion? I don't know how you would describe that as a percentage of the total biomass over, within a given year, 80% variability or something like that, or 20% variability. And then I started thinking about, well, if the IPHC doesn't have the authority over bycatch, then take a look at management of bycatch from the council side, and our management procedure is a fixed catch amount for bycatch. We don't have control over wastage, but there's a fixed or constant catch amount in the Bering Sea and in the Gulf. And so how do you mesh that? How do you bring those two together in a way that is better for the stock overall, and then we've got different management objectives, because one of the councils, it's an implicit management objective to allow enough bycatch to harvest other species. So that's where I went off the deep end.
Dan, actually, that's very relevant stuff, because one of the things that the staff is working on for the commissioners, for a work meeting with the commissioners in September, is the whole idea of accounting for total mortality and how we approach both accountability and management of this stock. So it gets into the issue of us understanding in a broader sense exactly what the whole mortality that's being imposed on this stock is, and it relates very much to what you're saying, Dan, about looking at what's the abundance of U32 fish, and putting aside the issues, can we actually estimate that correctly and so forth. But I think the idea behind this is for us to get a full picture of what the harvest rate on this stock is by all sources, not just by the directed fishery, but looking at it from a sort of a harvest type approach and harvest policy. What should it be, and what are then we can actually probably break this down into components, and that may be some of the fodder that we can use for discussions with the council and looking at a different kind of approach to managing this by the two bodies. But I mean, you hit the nail right on the head. We have two different bodies trying to manage the resource removals from one stock, and that makes a difficult proposition. So,
well, I guess just to follow up then, how far can the commission go in an MSE process on its own without that other component being involved?
Well, I think the issue is, from an MSE process, we can go as far as we want on it. In terms of operationalizing it to management, that's probably the heavier lift on this thing. But I think it's an important thing that we can actually make that process work through an MS, or we can examine that through an MSE process. Just killed all you. Should work. Is it on?
Yeah. Yes. Yeah. Bruce Gabris, Area 3A halibut fisherman. Just a couple comments. I echo a lot of the same things that others have already said, so I'll try to not go over that. In reference to the model simulation, it's good to have the model simulation as the concept to help people understand how that works and how it interrelates. But I also have a concern that there's potential for possible confusion, that the relationships established in that model are not based on, they're based on some assumptions. They're just for demonstration purposes only, and aren't reflective, potentially may not be reflective of reality, or not intended to reflect reality. So it's going to be important, particularly as others try to use this, to get to the meat of it, to where it is actually based on halibut and based on valid concepts. Because I think you run a risk of people put faith in something because the computer said so, and and we need to. I guess we just need to continue to emphasize that, and I think you have, at least in this initial go around. This is just conceptual for how it works, but we want to put some real meat into it, and I think that's when most of us are saying it's going to be very usable. In reference to objectives, just a couple things. In discussions, you said you want to minimize closures of fisheries. Some people have problems with that. They think that, hey, if a fishery needs to be closed, it just needs to be closed for the sake of the biology. So maybe we're not being clear that does not preclude a closure of the fishery. It's because it's always conditional upon maintaining 1 and 2. Then we try to maintain the fishery if you can at some level. So that was a feedback concern. And the other one I thought was a little bit interesting is people don't necessarily, it appears people don't necessarily have, fishermen don't have a problem with the 15% rule as far as a downtrend, but they seem to want to have, if there's enough biology to harvest, they want an unlimited up. So that kind of sort of doesn't work. But anyway, that was the feedback for that. Probably not necessarily in this order, but the other thing that comes up fairly often is fishermen are still trying to understand the relationship of the MSAB to the decision-making process. I guess if they figure they can influence the decision-making process, then they're going to pay more attention to us. And I'm quite honestly, I'm not sure that I had a good answer for that one, exactly how we're going to interface and influence that process, if at all. Last item here is there's every time you talk to a fisher, at least when I talk to fishermen, they're looking to grab any little bit of insight about what does the fishery and the biomass hold for the next season and in the future. So that, I said, you saw the same thing I did. So
Just to touch on one of the issues you had in there about trying to understand the MSAB's role in terms of the overall management process, this is what we want to talk about a bit tomorrow afternoon. Just in terms of both the governance of this group and to give you a presage, we're probably going to be looking for you folks to either elect or designate a chair or co-chairs from this process, because you folks need to take ownership of this thing in terms of what you're asking us to look at, how we're going to be looking at it, and what kind of results you want to see out the other end in terms of your comfort level of wanting to make recommendations to the Commission as to the results of examining these things. We want to be able to, these things, obviously we have to go through the SRB for these things, our Scientific Review Board, to sort of, validate some of the technical aspects of this. But it's very important to this process that this is something that is your process, and we're here to try to facilitate your examination of what your objective should be and what kind of management procedures you want to be using in this thing. Because at the end of the day, we're all going to go through this process and say, okay, we've done the best examination we can of the procedures here, and here's some of the procedures that we think that we might want to use in this fishery. This is the process whereby we examine those things, and so it's very important from the staff's perspective that this is going to reflect what you want to do, because you need to take ownership of this process.
This is Peggy from Hannah. I think everything everyone said has been repeated to me by my constituents and beyond, so I won't go over that. I think there's a tremendous amount of confusion still, which I also think is pretty natural because we haven't had the clarity, people at the table, well, I shouldn't speak for anyone but myself, haven't had the clarity to get to our constituents and answer all the questions that they have satisfactorily about this process. So I agree with a lot of what Paul and Brad said, and also what John said. The perennial issue of area versus coastwide still is alive. And what you just said, Bruce, I think is true. It's happening. We are starting to take ownership of it, but we also need to know why we're going to go with these management options and be able to explain it really clearly to people. And as the issues, and some issues are changing, bycatch is getting a lot hotter. As those issues change, other ones come up, we need the process to be somewhat nimble, and I know that's a little bit not going to work, but I think the key word is relevance to all stakeholders, that this process is, or it will be yet another body that maybe you get appointed to and it changes your life for a few years and things really don't, change after that. So I think we're kind of where I expected we would be in terms of understanding this process, and the staff has really gone full bore, and I'm real excited about seeing the demonstration of the model today or tomorrow. But I'm not getting a lot of different feedback from not only our members but others who are not processors.
Can I ask a question, Peggy, for that? You made the comment of not only what we're doing but why we're doing it. Did my comments earlier have help in that process at all in terms of why we might be doing this?
Yes, very much. I wish sometimes I could just channel you or say call Bruce, but I don't do that. So yeah, they do help a lot.
I think it is when we're faced with a lot of the scenarios that we're seeing here in terms of initiatives within the council process to look at bycatch reduction and so forth, and we look at what the impacts might be on the halibut resource, then this is the kind of tool we can use for looking at that. When I talked about the MSAB taking ownership and making recommendations, we're looking for a broad-based consensus, for want of a better word, about the sorts of things that if we're going to change our management procedures, we'd like to have a fairly good understanding that we've discussed this with the stakeholders, and that you folks have the similar sort of feeling about what things we should be doing here. Anytime we change a management procedure, it's going to have some impacts on there, and so our ideas about how this might be changed are going to be conditioned by what you folks have said in terms of what your objectives and the metrics that you're most interested in are.
And I do think we're getting there. We're just not leading the charge yet.
Tom Marking. Recreational fishermen generally are more interested in talking about hook size, clones, feathers, things like that. But there are a few of us that are either kind of masochistic enough that don't know any better, but actually sit down and look at this stuff and try to figure out what's going on. And the simulation tool is really interesting, but like the other said, when you actually put some real numbers, it's going to be a little more intriguing. But I sat down with a group of friends I have that are they're fairly sharp guys. Some are fish biologists in other areas. You kind of sit in the backyard and you start kicking some of these computer models around. You start going through past history, especially all the stuff that's been given to the here. And I tend to like to read. So you sit down with the computer and you start showing some of these graphs through the years, and some trends begin to come up. Just general observations. There's this kind of general confusion of S-bio, that they go from 8 to 20 with around 50, about 50% at 12 as far as sexual maturity. But and then Dr. Stewart's presentation in October on his harvest catch, past and present, has some really interesting graphs in there on page 6 and 7 about the bulk of the fish we're catching are between 8 and 12, and that same age group is maybe only 10 or 15% spawners. The rest are non-spawners, and yet they're part of the spawning biomass, and I still can't wrap my head on that one. And the general just began to think, are we overestimating what are really spawners, and if so, are we therefore over-harvesting, and if so, and we did this for about 10 years, how are we going to, what kind of pain is going to be involved to gain that 10 years back, and what is it going to take for us to get that biomass back that we overfished? If in fact we're not even overestimating the spawning biomass. And that's kind of on a backdrop. We watched the biomass continue to drop. Last year it dropped another 17 million pounds, although we went up in 2 million for our FCEY was. So you start getting a backdrop of all these graphs. I found Dr. Stewart's presentation really intriguing to me, and I'm sort of like I got stuck in quicksand. I can't seem to get by that. I'm looking at all those graphs thinking, there's all these graphs of the pink and the red, and they all fall off and drop down. The bulk of what we're harvesting is in the early section that are not spawners, and yet we're calling them spawners. And by the time we get out to 12 or 13, we've only got about 10 or 15% of the population left that are supposed to be doing all the spawning. But we've got a 34% spawning biomass. And honestly, I've got myself in a Gordian knot on that stuff, and I can't seem to, to get past that. I've got guys smarter than me that can't get me out of it either. But the bycatch, of course, is a huge issue for recreational guys. But the big sinking feeling was that the people we sat around is, are we overfishing these things? You watch historically, the biomass seems to be shifting from the north to the south. And that's not really an issue unless you go regional versus coastwide. But there's this feeling, it's like, is the biology really accurate on these things? Are we really defining these populations properly, or are we kind of just massaging numbers so that we can keep taking large numbers of fish? And we're going to run ourselves into a brick wall, like we did the yellow eye. And, we suddenly were faced this wall that you've got 20 years before you're going to recover, or 40 years, or 50 years in our area. That we're just looking at this 2078, we're going to rebuild yellow eye, and we're stuck until then. And that's our concern, that we don't do this to halibut. So we have more questions than answers, but the model was pretty cool. But the thing is, considering all these, these assumptions that we put in there, the variabilities of what we're catching, where the trends are going, how can the model of simulations, how can it reflect that, and how can it interpret that properly? So, this kind of like stock events. There's no guarantee that future performance is going to be indicated by past performance, and so far, we're sitting around, we're trying to build a better mousetrap here. One, do we have the knowledge to do this? A bunch of recreational fishermen, what can we add to this process? But two is, it's like, this is a pretty daunting task. How can we build a better mousetrap than what's being done already? And with any more accuracy, in 10 years, we're going to say, well, this was interesting, but that was the wrong direction. We totally went the wrong direction. That didn't work. So I don't know. It's, more questions than answers for me.
I wonder if I could just ask Ian to touch briefly on the sort of spawning biomass. Basically, it's the interaction of the maturity ogive and the selectivity ogive, you see.
Sure. I guess I'd like to start by saying I actually did that yellow eye assessment a few years ago. And the good news is that yellow eye are far less productive than halibut. Natural mortality for yellow eye is about 4% per year, and it might be on the order of 15 to 20% for halibut. So we're not looking at a 78-year period for appreciable stock change for halibut. With regard to the interaction between fishery selectivity and spawning biomass, you're right in pointing out that the bulk of the fishery catch comes from ages that are not 100% mature yet. And that's what makes it important that we get the right harvest rate, because we do need some of those fish to survive through a good chunk of the fishery, not just the directed fishery, but several years of incidental mortality associated with non-target fisheries and wastage in the directed fishery up to ages 8, 9, and 10. And then, as you point out, the bulk of the commercial fishery comes from ages 8 to 14, of which really only 12, maybe 13, 14 are fully mature. So it's not necessarily inconsistent that we have a fishery that exploits the stock before they become mature, but it makes management more difficult. If we had a case where these fish were unavailable to the fishery for whatever reason until several years after they had already spawned, the performance of the management would be far less dependent on the specific harvest rate we were applying to the stock.
I guess as the last point, there was just general confusion. It's like, what is going on with these fish that we've now got? We've now got fish that are 1/4 the size they were 20 years ago. I mean, what the heck is going on that can happen? And that's consistent right across the group. So, I mean, anyway.
Yeah, that's certainly one of our big questions as well, Tom. We have a major project underway on that with some external funding, looking at as many different ways we can look at. So we're looking at bioenergetics, we're looking at ecological competition, we're looking at fishery effects on the stock itself. So we're hoping to try to come up with some answers to that ourselves. But part of the issue is that it actually is not consistent across the whole stock. It actually varies quite a bit by region how much the size of age has changed in halibut. So it hasn't actually changed very much in the Bering Sea. It's changed a lot in the Central Gulf, not so much as we move farther south. So it isn't a very consistent process, and so because it may be a far more complex process than we currently understand it, this research is pretty important to it. But anyway, Craig.
I've been running a fishing vessel for the last 6 months, so I've been a little out of the loop. But this is my first meeting, and I appreciate everybody's comments, and I'm getting up to speed, so I'll just pass it on here.
Thanks, Craig. So I have a question for you. There's quite a few comments around here about objectives and whether or not we have correctly identified the objectives that are, and again, that this is an evolving process, so they're never going to be a finite set of objectives that doesn't change. That's part of this process, is trying to evolve our thinking about the objectives based on what we understand about the stock and the fishery impacts on it. So my question to you is whether you wanted to spend some time right now and revisit some of these objectives for the purposes of, it's going to help us, of course, if we can refine these even more than we have right now. If you wanted to spend some time on that right now, if we want to sort of look forward and looking at introducing what the operating model looks like. So, yeah, Adam. Thank you very much, Adam. So Chris Sporer, would you mind chipping in here?
Chris Sporer is going to try and chip in here. I'm getting technologically challenged here. Every time I touch my phone, the webinar crackles. But can everybody hear me?
Yes.
Can anyone hear me?
Yes. Everybody can, Chris. Thank you.
Can you hear me, Bruce?
Yes, we can. Can you hear us, Chris?
I can hear you faintly, but if I turn on my computer, if I unmute it, it echoes. So
Okay.
I'll just
You're coming in loud. You're coming in loud and clear.
I'll listen intently to what I'm talking about. Not much to add that's different from what we've heard already. One thing I just wanted to, a couple things just wanted to touch on. One, I just think put it on the table. We did hear quite clearly from the conference board that they wanted to be kept in the loop on this, and I think we need to be mindful of that and how we're going to report out to the conference board, because there is that old saying, if you get too far ahead of your own troops, they can mistake you for the enemy. The next one on the comments on the model, pretty much the same as everybody else. I think it's people are interested in it. I've used it a bit following the meeting, haven't used it since. I think it's good. It's a good way to show sort of what the outputs could look like and allow people to see what the outputs could look like, and I think it'll generate more interest once there's halibut data in there. With respect to objectives, talking to my constituents, they're under the understanding that, you know, this is an iterative process. The objectives are not carved in stone, and they're going to change over time. But they did have some questions on some of the objectives and seeking clarity. Particularly, one of the things is, you know, we're supposed to keep it simple. Have we got too many objectives? Also, clarity on what some of the objectives means. Just looking at the first four, trying to figure out, for example, objective number 1, how that fits with 2 and 3. We deal mainly with pounds, and yet we've got a minimum number of mature female halibut coastwide. You know, why is that there? How does it relate to 2 and 3? Why 1 million pounds? Why not 500,000? Why not 1 million pieces? Why not 500,000? Why not 2 million? So, you know, maybe there's a good reason there, but they'd like some clarity on that. And then, for example, on objective 4, well, I'd like to go through all the objectives, but objective 4, you know, someone looked at it and said, well, you know, boy, if you have a 1 pound TAC, you've met that objective. Is that where we want to go? I mean, we don't want to close the fishery, but, you know, do we want to get down to where a TAC is just so low that it doesn't really make any sense? So, you know, those are the type of things I think in going through the objectives, what I heard from our constituents.
Okay, thank you, Chris. Add comment on the rest of us. That was the one on the other objectives.
I think the question was, is that we're spending some time now discussing the objectives, and I think, it would be helpful.
Actually, there's one, I don't know if, is Shane Halverson on the line? He's not on? Okay, or he's not there, it's okay. Having said that, I think we're getting a fairly consistent commentary around the table about refining the objectives. The only thing I would preface the discussion with was saying that the objectives are reasonably easy to modify within this process. So I think some discussion about those. I don't think we should feel constrained by these things. As somebody said, as Chris said, I guess, you know, these are not intended to be carved in stone at all. As the same sort of thing as with the performance metrics, because we may decide in going through this that there are some other performance metrics that are actually very critical to us that we haven't necessarily put in here, and it could be things like average size of the fish in the catch and that sort of thing. So yes, let's have some discussion on the objectives we have here. Are there some alterations or changing, realizing that we did go through this last time a little bit, and that's where we ended up with sort of coming down to a sort of a set of overarching objectives within which we could have a fair amount of flexibility. So anyway, go ahead, Bruce.
That's Bruce Gabris. Bruce, you get to, when we go down the objectives, one of the ones, and it was Jim Balstring, I brought it up, about the million, you know, keep maintaining a minimum number of mature female halibut. And he threw out a number of 1 million, and that kind of stuck to the wall, but never was intended to be the actual real number, because who knows what that is. So at what point in time are we going to fill in those parts of the objective, and who's going to make that assessment to determine what is the right number? Because we got to pick a number at some point in time.
Yeah, that's a very good point, Bruce, and that right. It was just a number that was thrown out there, and I think Ian went back within about half an hour and said, like, we're way above that in terms of number of spawners. So it is a question that relates to the overall harvest policy in terms of if we're looking at spawning biomass depletion, what does that actually look like, and what does it translate both into biomass and numbers? Yes.
Well, I guess that's part of my question, Mike, going back to revisit the objectives. Just 2 comments on that. One is, I don't necessarily see a problem if objectives are either somewhat overlapping or appear to be redundant, because they're coming at the elephant from a different angle. So in some ways that could be a good thing, because it's covering a different aspect of it. And then the second thing is, at what, I'm still a little confused, at what point in time do we flesh out these objectives, say what do they really mean? And number one is the one that sticks out the most, is that we got an EG 1 million. At some point in time, we probably need to move away from the 1 million, and for lack of a better one, use Ian's scientific expertise or whatever and pick a number to put it in there, because that may change our opinion over here if somebody says that really needs to be 6 million.
I think to be fair to this, most of these were thrown out before we had tools available to really start to refine these things. And that's part of the issue here is having the tools available so that you can start to examine what range of values within some of these objectives are meaningful values. So when these were first developed, we didn't really have much in the way of a tool available to us, and we still have a fairly coarse tool. So it is an evolving process.
Who's on the queue? Me? Just to follow up on Bruce on your point about defining what X million fish should be, this process can actually define that number. It may be another objective that helps you define that number. There may be an objective, i.e., what's the minimum number of pounds for an economically viable fishery? And once you've established that number, you can go through and calculate how many spawning individuals that translates into, and that may define the objective. Then you can look at performance from a catch perspective as well as the biological perspective. So these things are iterative and they're open-ended to some degree.
If I can just follow up on that item, I think to me, there's a big difference between determining the number that's biologically sustainable for the stock versus asking us as a group of users about what is the economic impact. You're never. My personal opinion is you're never really going to get anywhere with that because everyone has their own impression depending what their market is and everything else. So, but we don't need to start with what does the market want and see if the biology can produce it. We need to start the other way around. Says what's available in the biology that we can harvest in a safe and biologically consistent fashion. So that's. I think we need to be careful about that we don't say what do we want in the market versus what can the resource provide us. We're just going to have to, do whatever the resource has. But the one of the reasons why I said we probably need to get a number was Dr. Stewart's comment earlier that says if we're okay with 1 million, that's way below where we're at right now. So it's really a non-objective. So that's why I'm interested in finding out, is 1 million reasonable? Then we're okay. Don't worry about it. But if it's something that we need to get, if it is significant that it needs to be much larger than that, then it'll become, then it potentially can become a restriction in the fishery. And that's why I would like to get a better number for that, even if it is, the learned people's best estimate.
Peggy?
Well, I would really like to see what we did after the 9. I think we have 5, so that we don't keep reinventing something that has already been improved upon. And I think it's really crystally important to be clear. I think it's just critical that we are clear with what those objectives are, knowing that we can change them, knowing that the words, the descriptors can change. That list is the best thing we have to go out to the stakeholders with. And what the job of the IPHC is to manage a fishery well. So thinking about that, those should be our criteria. How, not just what's going to make a viable fishery for the fleets, but what's going to, and be able to explain it, what is going to maintain this fishery for our grandchildren, support, keep a viable ecology.
Tom.
Bruce, I think we've got the answer maybe to what you're asking. I think in the information given to us last October, we've already got 14.7 million spawners now for 350 million pounds of biomass, spawning biomass, and we're holding steady at about 34.5% spawning biomass. I would say that's kind of a floor level that we wouldn't want to drop more below that, or we're going to keep sliding. So, if we're kind of holding, I think that's, let's stay above B30. I think that's kind of the numbers we already have.
So Tom, what do you think the number should be?
Well, I'd probably close to 15 million.
Well, I mean, then we need to, because $1 million is obviously not adequate then.
I mean, that's just out of Dr. Stewart's study, so.
Well, we did go through with you last time the sort of basis of the existing basis for the harvest policy, and there is a long presentation on that in there, and that's where some of those numbers initially started from, Tom. So, yeah, I mean, it's perfectly reasonable to say, okay, a starting point from here. We got to this point at our last meeting was that we have a starting point from the existing harvest policy. John.
Well, maybe I should have looked at that model a little better. There was another set of objectives, and I'm not sure what they were called, but I think it's one Peggy was referring to. And from my perspective, they are a little less scientific and therefore, from my perspective, easier to grasp. Because, and I don't want to pick this thing apart, I can get a sense of what this means. And yes, the science behind it will change as the resource changes, as the ecosystem changes, all that stuff. But just as an example, 1 million spawners, if they weigh 14 pounds or if they weigh 100 pounds, at some point we'll go back to what we had in 1980 when what we took out of the water was all above 60. I mean, I think we averaged 60 plus pounds. When we get back there, those 1 million spawners will mean a lot more than what we have now. And I don't think we know this, but I think that the quality of the roe of the potential progeny to come out of a larger fish might be more survivable than come out of a much smaller fish. So, I mean, I don't think anybody knows that, but that's certainly somebody's hypothesis. Maybe it's mine. Anyway, I'm a lot more comfortable with these overarching objectives, I see they're called now, because there are fewer of them. I think I can get my head around them. And if, to Peggy's point, if you're trying to get out to the constituents, this is a lot easier to do here. Because I think people will pick apart that list of 9.
If I can just comment on these overarching objectives are really the summary points of the 9 more complete objectives. Recall from our very first meeting when we had Rob Cronlund here come through, what we're really trying to do is evaluate alternative management procedures, and we have to somehow score them, and having these sort of qualitative measures up here doesn't really help us score them in a table sense that you can choose, or a decision maker can choose, hey, this is the path that will satisfy all of our objectives from a quantitative perspective. So Rob Cronlund was very careful in stating that you must have a clear set of objectives that states 3 things: what it is you're trying to measure, so biomass, what you want that objective to do over some time period, so there has to be, in 5 years, in 10 years, and then how badly do you want to do it. So you have to do it with 99% success, or you have to do it with 80% success. So those are the 3 kind of measures that ultimately go into defining the rows in the decision table that Ian produces each year. So instead of, as I said in last time we met, instead of a table that has a blue line, this process has actually identified cells in that table that help us define, hey, wait a minute, conservation is our highest priority, so we're going to look at those blue cells first and find the catch that satisfies our objectives, then move down the chain to the lesser or our hierarchical system that we're trying to develop here. So that's the reason for sort of more fully articulating these general objectives is that we really need to have a way to quantify how well these things perform with respect to our expectations.
Thanks, Steve. I've got Dan, Per, and Paul Ryle on the list here.
Thanks, Bruce. Relative to the 9 objectives, I know we the longer list. I know that we identified the first, I think, 4 as fishery objectives, and then we had our biological objectives, then fishery, and then other. I guess generally my suggestion would be that once we've provided you with some ideas of what they might look like, then I would prefer to leave it to the staff to determine whether, for example, number 1, whether that's redundant with 2 or 3, if we are going to use it, how would we use it? I guess that would be my sense of how to proceed on that one in particular. On 7 and 8, I think I commented last time that those, to me, they didn't seem to be realistic, because they're in the context of particular years, particular stock conditions and environmental conditions, and that's just not where we're at. So if there are some like those that you don't think are valid, I think we should hear that as well. And then if there are others that are not operationally possible, or whatever, I would defer or ask for staff comment on that.
Yeah, my apologies, this isn't updated, but my recollection from our last meeting is we had actually struck 7 and 8 from this list. Sorry, we left that in there.
And then again, back to what I said earlier, I would offer, just as an idea for discussion, a minimum coastwide biomass of X percent, of U32 biomass of X percent of unfished biomass in each year with a probability of Y percent. Let you determine whether that's valid or what the number should be, and if it's not valid, it'd be good to hear now. But
I think, Dan, you're hitting on, and this is part of the issue, is that we spent quite a bit of time talking about objectives without really having the tools available to us to help us evaluate how reasonable some of those things are. So we're at a stage right now where we're trying to put something in front of you so you've got a better tools and these things to help you with that decision yourself. So you're going to be able to look at some of these things yourselves and do this. So we felt we needed to get started in terms of how Steve was going to have to try and structure the model by getting some idea of objectives being there. But it's an evolving process, and these tools will help you to refine your own thinking on the objectives.
Yeah, mine was more of a question. In number 1 there, to maintain, a minimum number of females, is it possible to figure out what number that is to meet objectives 7 and 8? Or is that possible?
Yeah, it's possible. We have to make assumptions on what the size at age would be and all the other things. But yeah, you can certainly compute what that would be.
It'd be interesting to find out what the number would be then if you actually are looking for a number. Okay.
Yeah, thanks, Bruce. I kind of wonder whether one needs to have a metric in pounds or numbers of fish. And if we are to keep it, then I think it needs to be in pounds. And the probability that it's attached to right now, 0.99, is a pretty high probability. And so if it's a low number or low poundage, then it probably really doesn't matter. But you start getting to some number that is really that you want to be assured to. 99 is going to be something that'll be probably challenging to achieve. And so that'll come out when we start doing some testing, I'm sure. That's just not achievable when you start getting towards that border. And then I think, do we need it given that we have 2? And is there a benefit? I guess the question I have, is there a benefit of having both? But I personally am more attracted to the number 2 in that it's a percent of an unfished biomass, which is also an estimate. But number 2 right now has a high probability, and I think that's a wise thing to do, whether it's 0.95 or some other number. But I think it's a wise thing because it's an area that you want to avoid. I'd call it below that you're in a critical zone and threatening, what you are for a biomass, and you want to have some high probability for it. But right now there's not a period attached to it, and we might want to use something like over a 20-year period or some other number, whether it's 20 or some other time that's tied to
It says each year.
Each year, yeah. So once again, I think that's pretty high, but maybe that's what we want. And similarly with number 3, it's with each year again, and so is that what we want? or do we want it over a period of time? And I wonder too if there's something that needs to be stated about whether we want to be, if we are in the cautious zone between when it's below the upper reference point and above the lower reference point, whether there's something that says that what we do when we're in that area and want to get out of it.
That's part of the control rule in there, but how you're actually doing it. I sort of keep coming back to these things. We needed to start off with the objectives and sort of some broad stroke definitions, but I think when now we get into some of the tools things, it'll help you evolve your own thinking on this as well. Scott.
I like this discussion. I like going over these periodically, and like you said, I guess I like the idea of keeping a lot of stuff in there until we get a chance to play with it and then ruling it out. But the one I'm having the most trouble with, it's probably off everyone's radar because we're focusing on spawning biomass, but the one I'm having trouble with understanding, and maybe I just need to be refreshed, but I mean, we're trying to develop management or choose management procedures, identify management procedures for the directed halibut fishery through this process. And the objective on bycatch mortality, I'm not saying that isn't a great thing to reduce, but I can't figure out how any management procedure we evaluate for the directed fishery will affect bycatch mortality. I mean, it's like we could, to me, bycatch mortality enters the operating model as an assumption about what future scenarios are going to be.
I mean, this is a really good point, Scott, and it gets to the issue of this isn't just objectives for the directed fishery. It's objectives for the management of the fishery, whether it be total mortality, whether it be recreational fisheries, commercial fisheries. There's conflicting objectives between these things. So it's trying to look at the totality of management for halibut. So I don't think we should feel restricted to say that, okay, this is just about the directed fishery, because it's not.
If I could just follow up then, I guess what I'm having trouble is understanding the link between changing a management procedure and then how that will affect bycatch mortality. I mean, none of the management procedures we've evaluated so far have anything to do with bycatch mortality. I guess that's what I'm saying.
Yeah, you're exactly right. We haven't dealt with the issue specifically on bycatch. We noted too in our first meeting as the MSAB, we're kind of directly and indirectly connected to the North Pacific Fisheries Management Council and the Pacific Fisheries Management Council in their policies and how they handle prohibited species catch and bycatch for halibut. But it's not to say that we can't use this tool to come up with other issues. Say that the political will is there to have, dare I say it, the word allocation of bycatch to a specific fleet or fishery. Then we can use this tool to investigate how would this sharing program in the Bering Sea impact the directed fishery. If we can get, you know, a bycatch arrangement, or if we can get caps or tradable bycatch units among fishing fleets, or retention in the trawl fisheries and other things, and put that stuff on the open market, there's certainly all kinds of other tools we can investigate. But again, we're kind of married to the council process in that regard, because we're only really looking at policies, harvest policies for the directed halibut fishery. But we have to live in the realm of a much bigger issue.
If I could just elaborate on that a little bit, I think one of the things we're trying to do here, though, is broaden our thinking with some tools to try to let us at least inform some of that dialogue that we might be having with the councils as to, okay, here's some examination of what the impact of that particular procedure might be when it's broader than just the directed fishery. So again, this is very much like a think tank type of thing with some realistic objectives behind it. But I think we need to be looking at this in the broadest possible way we can here, recognizing that, as Steve and others have said, there is a split management authority for various components of removals from the stock, but I don't think we can make much progress if we're only looking at one component of those removals. So we need to be looking at the broader components.
This last question, or last comment, segued well into what I was talking about earlier with the need to clarify some of the objectives and management procedures. But I think it might be helpful just to provide a bit of a summary of some of the thoughts that I've had, or the Canadian side have had over the past little while. So and not speaking for all of Canada, but at a very high level, some of the discussions we've had are that objectives 2, 3, 6, 7, and 8, they seem clear enough. They merit some exploration. It's not to say that those values, 75% to spawning biomass over a certain probability or whatever it is, that those are the answers, but I feel those are good places to start. Objectives 1, 4, and 5 require some clarification. And again, it's not that they're wrong, but we need to clarify them to actually start evaluating them. For example, 4 says maintain directed fishing opportunity. Well, what is directed fishing opportunity? Is it the commercial fleet? Does it include food, social, ceremonial harvest in Canada? Is it recreational harvest as well? So some discussion around clarifying those points I think is important. One other comment that I heard around the table, specifically around, I think it's 7 or 8, about whether or not the time period of 93 to 2012 is reasonable. It may not be, but I think an important part of the MSC process is to not self-censor ourselves. If you want that, say you want that, run it through the simulation and see, well, you're never going to achieve it, so let's look at a new range. But if you want 20 million pounds, then ask for 20 million pounds, and you may see you can only ever get 15, but if you only ever ask for 10, you never know the difference. So I think self-censoring is something we need to be aware of, because that's the point of this, is to evaluate those different options. One other component, and it touches into something that Paul had mentioned earlier about the harvest strategy. Like domestically within Canada, we have the Sustainable Fisheries Framework, and it requires reference points for stock status, so cautious, healthy, critical zones. It requires that the harvest strategy and decision rules vary in relation to the reference point, so as stock status declines, you would vary your harvest rate. And then there's also need to take into account uncertainty when developing these reference points. So in my perspective, looking at the objectives 2, 3, 6, 7, and 8, objectives 2 and 3 state a possible limit reference point, and the stock reference points, the 2 points that we require to delineate the cautious, critical, and healthy zones. So that's 2 and 3. 6, 7, and 8, they kind of implicitly state a reference point, so where we want to be, a target reference point. But what we don't have is any sort of objective to account for this uncertainty. So if we're in the cautious zone but close to being critical, we should take a more risk-averse harvest. If we're in the high in the cautious zone, close to healthy zone, we can probably take a bit more risk. So I know the sable fish fishery has a sample objective. That might be a place to start. But, it's something that we can talk about later, I think, when we look at some of the other specific objectives we may want to consider.
Yeah, thanks very much, Adam. I think some of that falls into sort of the control rule aspect of this as well. So, you know, that's also part of the things that are being examined here. Yeah.
That was one other part that, and sorry, I came in 15 minutes late. I don't know if it was discussed, but I know at the annual meeting we talked about the harvest strategy and how the harvest strategy is going to be changed. And it's kind of a chicken or egg thing. Do we have a harvest strategy here that we start running through with the objectives, or do we develop a new harvest strategy first? I don't know. Has that been discussed? Do we know where we're going?
Yeah, we discussed that last meeting. I don't think you were here for it. But no, we really did, and I think we all sort of agreed that we should evaluate the status quo harvest rule, which we do have, and I don't remember the details of it, but it's something about 30%, 80% of the time, and it's like getting paid at DFO. You almost get your paycheck at 30% of the time, or
So I'm a little confused now whether we are, in this discussion, whether we're talking about expanding our objectives or we're trying to clarify them. Because if in fact we talked about removing 7 and 8 last time, but but now there's an interest in including them for exploration. I think there are probably several, 5 or 6 more that I could think of by the end of tomorrow to explore. But at what point are we going to clarify and reduce and move forward with something real?
Yeah, this could be really a NASCAR racetrack where we just keep going around and around on this. I want to reiterate that the purpose of defining these objectives is one, to map out the trade-offs. So the 3 primary axes we're always dealing with in these things is conservation, stability in the fisheries, so how much variability are we going to look at in catch, and then sort of economic sustainability is the catch levels or the minimum thresholds and biomass limits we're setting, do they work for the feasibility and economics of the fishery? If the biology of the stock cannot sustain those economic objectives, then we have to make drastic changes, reduce the capital investment in the fisheries, whatever it is, to make them work. Really what we're trying to do is choose objectives that identify those 3 primary axes so we can quantify how these things trade off against each other. You can't have more catch and a bigger biomass. If we could do that, we probably wouldn't have a halibut commission. So what we really want to say is where do we want to live on these Pareto curves?
Bruce, sorry.
Maybe this is Bruce Gabrus, 3A halibut fisherman. Just 2 points I'd like to make is, first, Scott, I appreciate your comments. You're talking about bycatch. Number 9 alludes to the whole issue of bycatch, but I would like to reference and refresh everybody back to this last annual meeting we had when the Area 4 fishermen were saying, the elephant in the room in Area 4 is trawl bycatch. You could reduce us to 0, and if we've got a sliding bycatch, if we got a sliding biomass, you could reduce the directed fishery to 0, and you still would have a problem. So I think that's the area that I think we have a responsibility here to holistically look at it. Of course, most of us are related to the industry, are longliners or something like that are harvesting in or the processing in, so it can't be like take it from those guys. But I think the holistic approach you mentioned, Bruce, it has to include all users, even though we may not have regulatory jurisdiction over those. This esteemed body needs to evaluate that, and if the recommendation is you go back to the North Pacific Council and say, look, you got to do something about that, then we need to make that a good faith effort to evaluate that, included holistically in the model. Scott, and that's, I think, was kind of your point. That's you have to evaluate that. You can't take it in isolation when there's this big user group there that's outside the purview of the body. And just a short follow-up on this, my second point is we talked about eliminating 7 and 8 last time. It's still here. We were talking about reevaluating these. I just want to reiterate that my concern is that anytime we're going to have an objective that is linked to a historical period of time for productivity or our understanding of productivity, and it's a biological system that's going to rock and roll to the wills of Mother Nature, I just get really uncomfortable with that, because that may or may not be a good time for the biological cycle. So that's why I was in favor of getting rid of those 7 and 8 when it's linking to a historical period. Because if the biology can't support that historical link, then of what value is it as an objective?
Thanks, Bruce. I think those are really, really good points. I would stress here that our ability to reject or take some of these things out of here should be based on our experience with trying to examine what their impacts are. And so I keep coming back to this idea that we've had this discussion without the benefit of having some of the tools available to us to actually sort of go through the examination and see how realistic some of these things are. So I think we should just be a little patient before we reject something outright, or before we want to reject a particular percentage or a time period. This process lets us look at things like alternative time periods or alternative percentages, and that's where the benefit for this would come into it.
If I could just have one follow-up on that. In reference to, let's just use item 7 on there. It's maintain median catch within 10% plus or minus the 93 to 2012 average. If we were so fortunate as the biomass was favorable and it would triple, of what meaningful use would it be to maintain within 10% of the historical average? Again, if the biology is such that the resource is cut to a third, of what value would it be to try to maintain that? That's really a cloaked economic objective, I think. And if we want to put in economic objectives, which was Steve, I think you said earlier about if you want to say what does the industry need to have a healthy economic fishery, I think that's what really those two are. They're really not biological. They're framed in biological terms, but they really are a level of economic activity. And if you can't maintain them, then the solution may be buyback programs, people go out of business, or whatever else.
Just in response to Bruce's comments, you're right. It may be that we can never achieve those, but the point is I think we should let the model actually run through the simulations to see, and maybe we need to pick a different time period afterwards. Or it just shows that we're never going to achieve those objectives, so let's try a different management procedure. We'll try a different harvest rate, something that still meets the conservation objectives and then meets those economic objectives. I think it's like Bruce Lehman had said, is let's see what actually comes out of it first, and then we can start calling objectives or changing them as needed.
Bruce, it's Chris Spohr. Can I just jump in here for a second?
Yeah, okay.
Sorry, I tried using the hand thing on the webinar. I just wanted to comment as well. I mean, there's nothing wrong with having economic objectives, is my understanding, that we want to have economic objectives. We want the industry to say, look, these are the things we need. And while we might, objective 6 or 7 and 8, maybe they're not perfect, and maybe we could go above there, but maybe this, by having them, it also says we don't want to go below there, and we want to see if, as Adam said, if maybe they're not realistic objectives. But I think the industry needs to try to articulate to you guys sort of what are the things that are important to us, and I think that's what 7 and 8 are trying to get to. And I'm not saying they're right. I know that actually we were the group that put them forward. I mean, I'm not married to them. I'm just saying I think we as an industry, or we as stakeholders, need to kind of say, look, this is what we want to see, and that's what I think they're trying to get at. And I don't think we should be afraid of economic objectives.
Thank you. That's correct. Paul?
Yeah, my earlier comments were all around the biologicals and conservation ones, and I left the 6 of them that are up there that were on the social economic ones alone because I wanted to hear from others around the room about those particular ones. I do think, though, that 6 of them seems a little bit too much, and it seems to me that probably some of them are redundant, and but I am sensing that people don't want to cross them off the list, and so if we want to keep them on, it just makes some things more challenging, and I kind of wonder why we really do need 6 social economic objectives. And it'd be better to focus it, would be my advice, but if they want to stay, that's fine with me too. And I would think, though, that on the 3 that I would call the conservation objectives up there, that 1 is redundant with 2, and I would say that we should take it off. And my earlier comment about we don't currently have one on the conservation side about what to do to move ourselves out of the cautious zone is one that I think we should consider replacing number 1 with.
Sorry, Paul, can you reiterate your last point there?
Yeah, well, right now, the way 2 and 3 are worded, number 2 talks about staying away from a target or a lower reference point, and which I would call the critical zone. And the number 3 is, to me, is around an upper reference point and something that, we want to be above. But we haven't defined a target, I don't think, and I'm not suggesting that we necessarily do, but there's nothing right now that says when we're between the lower reference point and the upper reference point, what do we do to say we want to get out of that area and be above it? So I don't think we've captured that at this point, I guess, Steve, is what I was getting at.
So that's part of the control rule when you're in between those two things. So how fast do you want that to happen? And that's what Steve was getting at earlier. When you're in a particular place, the procedure should define both what you want to do and how fast you want to do it.
Sure.
I think if I can restate what you're thinking, you're talking about maybe taking number one and saying if we're in the cautious zone, we should seek a procedure or seek or whatever to rebuild to the, what are those Neapolitan colors, the critical, cautious, and happy zone,
Yeah.
whatever it is,
Yeah.
within a 5-year period with a certain, NIMS has something called a rebuilding plan that has wording like that, and they use a thing called the puntilizer to do those sorts of things. So I think that's what you're looking for.
Along those lines, yeah.
Okay.
This is Bruce Gabris. I'd like to thank Chris for your comments on the phone over there, Chris. I'm not. I encourage that there needs to be an economic objectives, and I'm not objecting to that. I'm looking at the time frame and what I was saying. And this particular on 6 and 7, it just struck me as you were speaking that an easy way to resolve, or 7 and 8. 7 and 8 is what I was talking about. That an easy way to relay my concern of that, and when I'm saying these are really economic objectives, if we could convert the plus or minus 10% of 93 to 2012 and over 70% of 93 to 2012 average into terms of poundage, that would, to me, would be very useful, because they're saying there's an economic objective for those social and economic reasons. We want to maintain this level of harvest and get rid of the, I don't know what the 93 to 2012 average is, but I do know what X million pounds is. So if we're going to explore that, could we at least in parentheses after that say what is that range that we're going to shoot for? That to me would clear up in my mind that it is an economic objective where we're trying to maintain a certain level of the fishery. So that would help me if you just put what does that represent in terms of pounds?
At the risk of putting words in Chris Spore's mouth, which I'm happy to do, I think it's important that you do maintain some sort of empirical objective. If you strip those two out, if you look at the whole list, everything is ratios. And stock assessment models are really good at estimating ratios, but the absolute values were really horrible at estimating the absolute abundance. But we can tell you how much this declined by. So I think it's really nice to, at least from an economic perspective, to have an empirical value. Whether you want to say we don't ever want the catch to fall below what it was in 1977 with a 95% chance, then you have an empirical value in there. But if you say some ratio, then it's really difficult to judge.
Can I just get one follow-up on that? In 7 and 8, we're talking about harvest. We're talking about catch. I mean, that's a known number. I mean, I could go back in your history record.
Yeah, and if we...
So, I mean, I don't see an issue. I don't know what that means in terms of years, but I most certainly would know how that would fit in if I knew the poundage of that. So I would ask that. I mean, there's no Ouija board magic there. I mean, it's the historical catch and take the percentage of it. So if we're going to keep them, I would like to say at least in parentheses after it, tell me what that reflects in poundage so we can evaluate it against what we have.
Yeah, my point was if you eliminate those two objectives, then none of the remaining objectives have any absolute scale.
Well,
and that
I thought I was
the point.
arguing that we should keep them. We just want to clarify.
Yeah, and I am
poundage.
supporting your argument.
Oh. Well, thank you.
All right.
Well, back to what Paul was saying, as the most mature female in the room, I think it would be fine to eliminate number 1.
Okay. Why don't we take a 15-minute break, and then I'd like to come back and have Steve start to do the introduction on the coastwide operating model. Dan?
If I might, Bruce, just make one more comment, and that is that if it's the intent of the group, and Bruce, you believe that we should take a broad approach in MSC, and the Commission intends to, including exploring management procedures for bycatch, I think you have to be very clear in communication with the council about what it is you're doing and allow the council to interact appropriately, whether that might be recommending some other stakeholders participate on this body or other things yet to be determined. But I do think you have to be clear. I'm certainly happy to go back at our June council meeting and speak generally to the intent to do a broad look at it. But communication is critical here. Well, but this is a commission process. And so if the commissioners and you feel that this is what the commission should be doing and the commission intends to explore management procedures as part of its process, it's more than just me communicating back to the council.
So we'll come back at about 2:30. We're back live. Steve, would you like to introduce the operating model? Your patience is appreciated. Before we get started on that, I think just to go back to our previous discussion on this, Steve and I were just talking in the break, and I think part of the issue here is that, as I said, we're a little bit out in front of the process here because we're talking about evaluating some objectives without actually having any tools to do it here. So this is a good segue into Steve presenting, hopefully, at some point, the tools to let us make some of these evaluations and some decisions on some of the objectives. But please bear with us for a second.
Thanks, Jay. Get my mouse. Okay. Feliz Cinco de Mayo. What I want to do is sort of give you a bit of a review of the MSC process in terms of why we need an operating model, some of the status of the current tool that Katarina and I have put together in the last since the annual meeting. We basically started this, and then follow up with an example where we actually investigate the use of different size limits in a halibut-like fishery, and show you some intuitive and some counterintuitive responses from imposing size limits. And some of these address some of the issues that we brought up at the last meeting. First, acknowledgments. On your way out today, Tamara at the front desk, you can all thank her for the pop goodies, and those of you who are high-grading M&Ms out of the trail mix, you want to thank her, and for all her travel arrangements and everything else she's done. She certainly makes this thing run happy. Second, Katarina War from UBC is a graduate student who started at UBC the day I left UBC. Has been down here working with me, developing an operating model, not only for the Pacific halibut, but it's a generic operating model that we're developing for Pacific hake and many other applications. Some folks in France are using it for the tuna models, etc. So this has been a very global product so far. We've had people from France, Japan, South America who are all using this, not only using this framework, but contributing to the framework. So we've not only had Katarina and myself, but we've had, I think, close to 20 different programmers now contribute to this project. And we've largely done this through a Facebook-like operation where we're using social coding, and people basically download the code, play with it, make cool things, and then upload it back up to me, and I can look at their work and say, hey, that's pretty cool. I'd like to integrate that into our project. So some of the names are big names. Dave Fournier, of course, who invented AD Model Builder, has really helped us build this project. So it's a pretty exciting piece of work. Just by way of review, this presentation is going to sort of look at where we were at the last few meetings and then talk about the importance of an operating model. I want to introduce you to two new models that we use in this process, an integrated statistical catch age model, also known as ISCAM, and then a new model which we affectionately named MILCA, and then how we condition this operating model on the halibut data. So this is the reason why Ian's office is next to my office. The two of us are sort of really giving each other a lot of feedback on what goes into the assessment model and what's required from the assessment model to go into the operating model. Again, walk you through a simple example, just looking at the implications of size limits on our harvest policy. I'll follow up with a to-do list just so you don't think that everything that we show you here today is up and ready to go. And then we'll follow by more of an open discussion with a lot of the feedback we've received already so far. Again, I want to reiterate, this process is about assessing the consequences of, say, the status quo and alternative management procedures, and then expose the trade-offs across a range of management objectives. So we've had a big discussion about management objectives, and it's important when you think about defining those objectives that they don't necessarily have to be redundant, but they should expose the trade-offs among economics, biology, and conservation. We're really dealing with the axes of biological sustainability, fishery sustainability, assurance of access, minimize the bycatch, and serve consumer needs. These are our overarching objectives in this process that we've defined so far. I shouldn't have to go into this, but I will. What is an operating model? Really, it's a big mathematical and statistical model that's used to describe the actual resource dynamics in simulation trials. Really simple to write down that sentence, very difficult to actually implement that sentence into a set of equations that reflects 6 independent commissioners who are making decisions about how we go in the future. And then you ask me to do this 40 years from now, what those commissioners are going to say. So again, it's simulation work, so it really doesn't matter what they say, but we can certainly mimic what we think they might say. The other purpose is to generate data and how the fisheries or the process will respond to different management procedures, and we project these things far into the future and make guesses about what will happen. One of the things I want to do to keep in mind when you think about things that influence the dynamics of the stock is to immediately categorize those variables into things that we can manage, like when and where to open and close fisheries, and things that we can't manage, like how recruitment variations affect climate. There's always so many people who are really interested in throwing a lot of money and trying to figure out how the climate predicts recruitment. And I always question them, well, why would you want to do that? You can't manage the climate variable anyways, or the small scale variables that you maybe think that are important. So keep that in mind. Always break these things down into two categories, whether you can manage it or it's something you can't manage it. We then predict things like biomass catch and stuff into the future, and then use these things to calculate performance measures and ask how robust each procedure is to these alternative performance measures. For example, we showed you in the last meeting the performance of 2 different harvest control rules in the same populations, where you had the 30-20 harvest rate rule, adjustment of the harvest rate based on the current spawning stock depletion, or using a rule that just says we're going to have a fixed harvest rate of X%, and we're only going to allow the catch to vary by as much as 15% per year. And we showed that the fixed harvest rate rule really results in a much higher spawning stock biomass, but that there were some consequences to do that. So overall, you got a higher median biomass when you integrate over the different scenarios about whether recruitment was driven by an environmental effect or whether we had bias in our estimates of bycatch. And then we looked at the median catch. So yes, you do get a higher biomass, but you only obtain about half the amount of catch you could achieve from the other rules. So this was one way to sort of contrast how these two different rules or management procedures would perform in a policy arena. Okay, that was a simple model. So now you're going to have to start doing your homework. No more football, no more hockey. We're going to talk a little bit today about the guts and glory of iSCAM and MILCA. So iSCAM was a model that I started developing for DFO actually back in 2010. It's an integrated statistical catch age model that accommodates many different types of data sources. And then MILCA is a German chocolate cow, and it's also the name of our operating model. And it's right there on the table. That pencil case is when we're sitting down just writing the file name, what are we going to call this thing? That's what I saw on the table was the pencil case MILCA. So there it is. So these aren't showing up there. Okay. So I always have to remember about the internet. The history of iSCAM, again, I developed this back when I was at UBC to assess multiple stocks of herring in British Columbia that also had multiple fisheries. So it's a similar situation here with the halibut fishery. So it's pretty amenable to adapt the code to the halibut situation. One of the big challenges in that herring project was disseminating the model and the code to DFO scientists so they would actually use it. So what we did is developed what's called an open source project where the code was put on the internet and people around the world were allowed to access it and use it to build their own models. And over the 4+ years now that it's been available, I've had about 30 people from places like Australia, South Africa, South America, east coast of Canada use it to assess many of their stocks out there. So this thing is not only my project, it's a much larger community that's really contributed to this thing. I own it, I guess, but it's really been the likes of Chris Grandin and a few folks at DFO who really helped shepherd and pioneer it for other stocks. DFO Robin actually used it with the Pacific Hake assessment a couple of years ago. Pardon me? And Pacific Cod as well. It was used for some jack mackerel work, looking at MSY-based reference points for multiple fisheries. Traditionally, the MSY-based calculations, things like FMSY, are only done for one fishery. This is the first piece of code that's actually sat down and tried to figure out the optimization of how you should allocate the resource to one fishery versus another fishery based on the selectivities of those fisheries. It was also used here at the IPHC when I first started here to examine our new models that Ian developed to deal with the retrospective bias problem in looking at the best practices for how we examine selectivity in the fishery. That was the major change that Ian put in the halibut assessment model, and I evaluated it using this platform. Since last summer, we've put a huge amount of effort tearing this model down a bit and rebuilding it so we can now accommodate multiple sexes, a multi-fleet, multi-area, and multiple stocks for the purposes of answering some complicated questions that only the halibut fishery seems to have. And then the next part of it, based on some advice from our colleagues, Alan Hicks here at the National Marine Fisheries Service, and a lot of help from folks like Dave Fournier, we developed an independent population dynamics model called MILCA, which basically is almost like Lego. You got this assessment model and you can snap on this operating model, and after the assessment model is done, the operating model will take over for you and basically run the whole process for you. And you can snap this thing onto stock synthesis, any model that's out there. So we've done a huge amount of work on that end of it. Sure.
Could you go back one slide, please? So kind of a dumb question, but when you said that in 2012 the best practices for estimating selectivity, I'm sorry, what was that? Sorry, the one above it, 2011, MSY-based reference points for multiple fisheries. And you said that that was based on different selectivity among the fisheries. Was that the only difference?
Yeah,
What
there's
about time base?
two issues there. I'll give you the history of why it came up. In the BC herring fishery, there's 3 fishing fleets. 2 of them focus on the herring roe fisheries, and they harvest fish when they're sexually mature, actually right on the spawning grounds, either using a gill net or a seine gear. So those are the 2 gears. There's a 3rd gear that harvests herring in the wintertime, and it's for the food and bait fisheries. So they're sexually immature fish. They harvest them about 2 years younger than they would in the seine fishery. The disaster in Fukushima happened in Japan, and the herring roe market just collapsed. So there was no market for roe. So the DFO managers, without even consulting the assessment scientists, just reallocated the entire resource to the food and bait fishery. And we, myself mostly, jumped up and down saying, wait a minute, you're going to have a huge overfishing problem, because now you're catching sexually immature fish, and you're taking one of the largest quotas we've ever taken out of this. So this is why I was on sabbatical in Hawaii. So I sat down and said, this is an optimization problem. And being besides a hockey player, a recreational mathematician, I sat down and figured out the math on how to solve this problem. At the same time, Jim Iannelli, one of our SRB members, was in Chile trying to deal with the allocation problem for Russia, Japan, a bunch of countries, to deal with the jack mackerel. And so they contracted and consulted me to deal with the same optimization problem for those countries for them. So what we've developed here is an algorithm that deals with the optimization problem from 2 perspectives. One is just a pure optimization problem, and you get what you get based on your past behavior on how your fishery operates. Or 2, you can come up with an allocation and say Japan gets 20%, Russia gets 80%, and based on the selectivities of those 2 gears, what fishing mortality rate should you assign to those 2 gears that would maximize the sum of yields for both countries? We have the same problem here in the halibut fleet. We have all these different areas. We have by area fleets that have different selectivities by nature of the distribution of the biomass. So how do you allocate the fishing mortality rates? So one of the questions we heard today in our roundtable discussion was area-specific harvest rates. So here's an algorithm now built into a piece of software that already exists that can address that question. And so we're pretty excited to start getting the real data put into this thing to ask and answer these questions.
And my second question was the last one, next to the last one, refers to multi-stock. And is that multi-stock for halibut? Does that mean spatial stocks or what?
It could be used in a multi-stock spatial thing. What I'm proposing to do, I wear another hat here at the commission besides this MSAB board. I'm also the principal investigator on the Size at Age project. And so one of the things we wanted to do was model a distribution of populations that have fast-growing halibut and slow-growing halibut, and asked, has the size at age, changes in size at age we've seen been a result of the cumulative effects of size-selective fishing? So if you're a fast-growing fish, you're going to recruit to the fishery faster and earlier in life than a slow-growing fish. So when we go out and sample the population in our setline survey a number of years later, what we would expect to see is if the exploitation rates have increased in an area, we would expect to see the size at age, the average size at age, drop over time. So that's why we built this infrastructure. And that's, again, part of a big integrated modeling framework that we have in our NPRB proposal. I'm a big fan of killing 2 birds with 1 stone, or 8 gophers with 1 bullet. Okay. Some of the features I've talked a lot about, and largely many of these things aren't that important, but Estimation of total variance, the weighting of data has always been a very controversial issue in fisheries stock assessment. We really have a nice system here that allows us to quickly explore alternative weighting systems for how we deal with observation error versus process errors, composition data. We've had a number of contributors just in the last couple of months from New Zealand, and Dave Fournier and Nanaimo coming up with alternative likelihoods to deal with composition data. None of this stuff has been published yet in the literature. It's all sort of, actually some of it has been published in the literature. It's all sort of cutting edge stuff, so we're pretty happy to see that this is the first RFMO in the world that's actually using these new technologies. We have all kinds of interesting functions that involve parametric and non-parametric selectivity functions, much like stock synthesis does, so we can repeat many of their assessments. We have some other features that help us reduce the number of parameters we're estimating using interpolation techniques. I've already spoke about the MSY base reference points for multiple fisheries. We can do both retrospective and prospective analysis. And when I say we can do it, I mean it takes like a minute to do it, and we're really quick at it. We have explicit spatial representation, and we have the capacity to automate simulation experiments. These are my favorite because I can sit down on my computer, set up things to run for 5 or 6 days. I'm still working, my computer's still working, and I'm on the ski hill while this is all going on, watching it run on my iPhone. We have automated protocols for doing management strategy evaluations. So one of the nicest features I think about using iSCAM and why it's so attractive to people is when you want to do management strategy evaluation, you literally type MSE and the whole thing gets spun off. Whereas the traditional approach of building building an operating model and management strategy evaluation involves years and years and years of work developing the infrastructure, usually in a separate platform. We've done this in one single platform, so we can continue to do this. The history of Milka, it's not even 4 months old. It's our new baby. Probably the most attractive feature of it is it's probably one of the most compact pieces of computer code I've ever written, which is a really nice thing. It's like having only 2 lines to moor up your boat than having to use 20 lines to moor up your boat. When you have a few lines of code, it's really easy to find out which line broke, and it's really easy to fix. So we're pretty proud of this things. One of the interesting features of Milka is that it literally is like a piece of Lego. You can snap it in to the bottom of any assessment model, and it automatically inherits the data structures. Now, this might sound cool to you, but to a computer geek, this is really cool stuff. Mostly, what's cool about it is that when the assessment model changes, and it will change, our operating model inherits those changes without having to write any additional code. So because we've written this piece of code as a nice object-oriented program, if Ian starts adding tagging data or something like that to the assessment model, the operating model will automatically inherit those data structures. So it just streamlines the amount of work I have to do in the future. And it'll probably free me up to do other non-administrative things. No, it'll never free me up. The stock dynamics, I'm going to come back into these features a little bit more with more information on terms of what sort of questions we can ask. But we do represent the stock dynamics in terms of explicit rules dealing for sex, area, stock group, recruitment, and the advection and migration of individuals. We also have subclasses that deal with the fisheries dynamics. So we have explicit rules for fishing fleets, which areas they fish in, the selectivity or the availability of fish in a given area, as well as the ability to implement minimum size limits and maximum size limits, so you can have slot limit type things. The one we haven't put in is the reverse slot limit. That's something totally unique to the halibut fishery, and I won't. Advection is sort of like going from point A to point B, which is different than migration, which is going to point A to point B and coming back to point A. So migration is actually defined as a closed loop. Advection is just, or you're being moved in a given direction by recruitment currents or currents. Generally, fish larvae are advected to areas, and a lot of the spawning occurs in a given area, mostly because if they happen to spawn in an area, the advection of those recruits took them to favorable grounds. Those are the ones that survive, and if they know how to go back to where they were before, they'll have that thing. So advection is really important. When you're dealing with a spatially explicit model here, everybody talks about the migration component. That part's easy. We can tag fish and figure that out. Where do you put those initial recruits? That's the hard part we don't have data on. But that's probably the more important question that we can't actually get the data for.
So our migration from west to east and then south, is that migration? Or is that advection because they're not coming back?
It's probably more advection or dispersal in that case. Migration is usually thought as a seasonal thing, like the wildebeest going around the Serengeti, those kinds of things in the ecology in Wales. It's not kind of a one-way trip for halibut. I'll bet you at a smaller spatial scale, there probably is a seasonal migration associated with the spawning migration. We just don't know that kind of details yet. Yep. Yeah, currents, dispersal by currents. Scientific data. This is always an interesting question. We have to review every year a whole bunch of proposals on new data we want to collect, and here we have a tool where we can actually ask the question, well, how informative will it be to sex our commercial catch data, and what information will that provide? We can ask questions regarding the accuracy and precision of age or size composition data, weighted age sampling, etc. And then the stochastic variability is really dealing with how recruitment varies with or without any sort of environmental effects. Size at age sampling is also a random process that's not so random. It's actually, size at age has to do a lot with how we sample fish to begin with. We simulate, again, errors, observation and process errors in our relative abundance indices, and of course our ability to actually implement the harvest policies. I want to sort of give you a kind of table view on how this thing it looks in the user interface when we use it. For each fishery defined by a row here, if you go across the columns, what we can do is we can specify the size limits associated with those fisheries. We can also specify the average discard mortality rates and even perhaps the CV of those discard mortality rates for the fisheries, and we can determine whether or not we obtain information that's sex specific or does not have any information regarding sex. And then for each of the statistical areas that we're modeling, we have a flag whether or not the commercial fishery is allowed to access that area, or the bycatch fishery, or whatever it is. So if you ban trawling in 2C, for example, we can certainly shut down the bycatch fisheries in area 2C and just simulate those effects to see how they go over time. We can also go into the set line survey and turn areas on and off every other year and ask the question, should we survey all the areas every year, or can we save money doing it other ways? This is sort of more of an interface thing that Katerina and I use every day. It's sort of our status of where we're at on our to-do list. And what we're showing here is the main routine inside Milka called Run Scenario that does all of the engine, it does all the work for you. And then over in the right-hand column, there's a column there called Status with some plus symbols and empty boxes and dash symbols, and up at the top there's a legend, whether we've implemented those yet, whether it's partially implemented or implemented and we're still testing it, and then a nice little apple signifying a real computer to show that the routine is good to go. What you can see here is there's no apples in that column. What I'm standing here before today is I'm kind of like a property developer, and I've got a new condominium I'm going to sell you all, but it's still surrounded in scaffolding, and I'm going to take you up and down and show you around the building, but you're going to have to put your hard hats on and appreciate the beauty you're going to see in the future. Okay. So let me step back and jump into a little more details with regards to the questions that we can deal with. The first point, again, about inheriting data structures from the assessment model. The operating model represents a huge time investment, and it's really conditioned and married to the results of the assessment model. So each and every year when we make minor tweaks to the assessment model, you've never done that. When we make minor tweaks to the assessment model, we're going to have or change our perceptions of how well the operating model will perform, or sorry, the type of data and results that will perform. Probably the biggest time investment is writing the code to do a certain thing in the routine. And what we've built here is essentially a piece of code where you can write that code once and it will be inherited both in the operating model and the assessment model, which is a really nice feature because you only get one chance to get it wrong, and then if it's wrong you can find it real quick and fix it. If it's wrong in both places, you don't know which one's right or which one's wrong, which causes a huge amount of trouble. So this is saving General Electric millions of dollars in using proper programming techniques. Traditionally, what happens when you have an assessment model that changes, you'd have to go in and rewrite the operating model code. Well, this code will probably take me 2 years, well, only 18 months now that Katerina has shaved off 6 months to write this. So you don't want to have to be rewriting this every year. And you've seen this in other projects like the BC sablefish fishery. You know, they sort of run these things once every 3 years, and then in between, Sean and Rob are constantly tweaking and modifying the outputs. And that's pretty much all Rob does now is really deals with managing this product. So the inheritance part of this is really important. Regarding stock dynamics, again, we have explicit rules for sex, area, stock group, recruitment, advection, migration, etc. These rules will allow us to address questions such as, does sexing the commercial catch improve our estimates of abundance? So Ian showed at the annual meeting this past year what the implications were if you changed the catch ratio. Is that what you did, Ian? The sex ratio of the catch, and alarmed us a little bit about how important or how sensitive that result was. So we can actually go in now and simulate traditionally, or what we do now is just collect catch information but no sex information in our port sampling. If we could somehow sex the catch at sea or get information on the proportions of males and females in the commercial catch, we should have more reliable estimates. We can test that. How do area-specific regulations impact the status of halibut? So we've talked a lot about area-specific harvest rates. So we can go in and change the harvest rate in 2A and jack it up to a big number or put it down to a little number and ask the question, how does that impact the stock? How does it impact the fishery in 2A? How does it impact the fishery in 2B? So the implications of advection and migration in the directed fisheries yield can also be explored through the use of alternative migration hypotheses. Regarding the fisheries dynamics, again, we have explicit rules for fleets, areas, selectivities, availability, because fish move from one area to another area. So how do area-specific bycatch caps, the prohibited species caps that we have in the North Pacific Fisheries Management Council, how do they impact our harvest policy? I've been doing a lot of work in this arena for a conference next week, and discovered, I should have saw it in the writing a long time, but discovered that really our harvest policy is largely a function of the decisions that are made by the councils in terms of how they manage the bycatch or what levels they set to the bycatch at in other fisheries. So we really have to start integrating those changes into our harvest policies. How sensitive is the U32 selectivity assumption for the commercial fisheries? Another important question. It's an assumption that we have. We've looked at it indirectly. Here's a tool where we can look at it directly and then ask how sensitive are our harvest policies to these assumptions. And then I think this is Peggy's favorite. What are the benefits of having an upper size limit in the directed fishery? We can look at those as well. Regarding scientific data, again, there's sex-specific data on catch that already exists, age composition data. We have some size composition data, weighted age sampling. We now have the capability to quantify the value of new and existing research programs on the utility of those programs for better decision making. So we could conduct, multi-million-dollar juvenile survey and ask the question: will we recover multi-million dollars of fish that justifies the survey? Or should we just go and do the survey and play with live ammunition and see what happens? We did that in Pacific Hake, and it didn't pan out so well. Half the time, the recruitment index sort of jived with what we were seeing in the assessment model. The other half of the time, the recruitment index didn't jive with it, and we would have predicted large recruitment events, and then they wouldn't materialize. So the planning stuff becomes really, really important. Again, sex and commercial catch data, real-time migration rate estimates from high-tech geomagnetic tags deployed as part of the annual survey. You can imagine all kinds of things you could dream up. I think we have someone here who has been dreaming up that particular question. Lastly, dealing with stochastic variability. There's always stochastic of events. Essentially, this is what the MSE process is trying to do, is find a procedure that's robust to a lot of these events. One of the events that's we're all dealing with right now is biases associated with estimates of bycatch in partially observed fisheries. So we can simulate these biases and then ask the question: how robust are the results of our estimates to these impacts of bycatch inside a computer model? Questions? I want to shift gears here for a second and talk about conditioning the operating model. You're looking at real halibut data here. Cool. So you're right on the verge of getting to play with shiny with real halibut data, and that probably the next time we meet you will be doing that. And the first thing we've been doing is reconstructing the historical biomass using the iSCAM framework, which is very analogous to the stock synthesis model that Ian was using that he showed you at the annual meeting. So we're able to sort of reconstruct the historical picture right back to 1888. One of the technical problems of doing management strategy evaluation is computation time. And so the first step is sort of conditioning the historical operating model. And this model, takes a few minutes to run on the computer. It's not a big deal, and that's no problem for an annual meeting. The problem is when you start doing management strategy evaluations, you're talking about doing hundreds of thousands, if not millions, of assessments to evaluate the distributions of your properties. Well, if these things take 2 minutes to run, 1 million times 2 minutes is 2 million minutes. That's a lot of days on the ski hill when you could be going in here and figure out. So one of the things that Katerina and I have done is we've put into the model where you can still use the historical data and tune everything, but then we've put in a prospective year where we can actually start the model in an earlier year. And we're in the process now of trying to fine-tune that prospective analysis so we can match the historical figure and still have all the parameter information and everything else to predict what the spawning biomass is going to be that's consistent with the full model scenario. Ian's done some really neat papers on the value of historical information. We really don't want to lose that perspective. Bruce, question?
Yeah, just one really quick there. You see the big spike back there in 1880? How reliable is that number, and how is that derived?
Sure. You'll notice along with the big spike, the band of ribbons represents basically the 95% confidence interval around that, and that's anywhere from 600,000 tons or 600 million pounds up to nearly 20 million pounds. So it's not very reliable We don't have much data going back there. All we really have is catch data. The data start, what, in 1923, Ian? Yeah, so where you can see where the confidence interval gets really narrow is when the catch at age data start to come online, and then our uncertainty gets much, much smaller. This is a quick and dirty fit. I didn't spend as much time fitting this model as Ian does, and that's part of the next steps in our process. All right. So I just wanted to throw that out there as bait that this thing is actually moving along at a rate that's been, in my professional opinion, far too fast. And I think we do need to, I certainly need to sit back, take some time and write and document more clearly what we've done, present this to our scientific review board and have them vet everything that we've done, because we really have cut a lot of new teeth developing this product. I want to walk you through now, like we did in the previous meeting, a simple example where we're just going to focus on size limits. I'm going to use a generic age-structured model, the same data we showed you the last time we did this. It's just one fishery, one stock, one area, one sex, a halibut-like fish. I'm going to present you two scenarios. Again, these are things we can't manage. One is where recruitment is independent each year, varies about a stock recruitment curve, and another one where recruitment is actually driven partially by some environmental factor that basically imposes an autocorrelation. Basically 80% of the environment this year will persist next year. So if you have good recruitment events, they'll persist for 5 or 6 years. If you have poor recruitment events, they'll persist for 5 or 6 years. I have 4 procedures. One, just an example where there's no size limits, and we just use the selectivity of the fishery and see what happens. One where there's an 82 centimeter minimum size limit, and then we use a fixed harvest rate where we fish at FMSY. Then management procedure 3, we have this slot limit between 82 and 108 centimeters, and again the same fixed harvest rate at FMSY. And then we've used the DFO Neapolitan type. Why can't I never remember? This is why I don't work for DFO. Cautious, critical, and happy zone, where we have the 30% and 20% as the threshold and limit reference points. And again, you're fishing at FMSY if you're above the limit, or sorry, the threshold. You've all seen this. We no longer call these worm plots. Everybody just thought they were too much about gardens and not about real fisheries data, so now we call them tulip plots because they look like tulips. Thanks to Rob Cronin for that flaky name. Here's just an example of how the spawning biomass, yeah, the flower, yeah, like the tulip, the flower.
We want to change the name, Steve.
Please.
Yeah, kelp.
Kelp, thank you. Kelp Plus, that's a good one. I like that one. Someone's got an original idea around here. These are just the spawning biomass trajectories. On the left is the scenario where recruitment's independent. On the right is where recruitment is driven by some environmental factor. And you can see under the environmental factor, there's much more variability in the stock. And that's shown by the width of that kelp blade. Nice. So here's some blue and pink kelp. In the pink one, we have the management procedure 1, which is the fixed harvest rate with no size limit. And in management procedure 2, shown as blue, teal, whatever color that is, we have the 82 centimeter size limit. And what you can see is the size limit does what we hoped it would do. It allows us to conserve some of the smaller fish that would translate into more spawning biomass in the future. And one of the assumptions we've made here is that if you catch a fish that's less than 82 centimeters, you throw it overboard, then there's a 15% chance that that fish will die just from discard mortality rate effects. So the general message is the size limit is good for spawning biomass. If we look at those same two scenarios now, but now look at the catch you would achieve from those fisheries, the fixed harvest rate, there's no size limit. You get roughly maybe 5-10% less catch with the fixed harvest rate, no size limit. Using the same harvest rate, but an 82 centimeter size limit, you get a little more catch, about 5-10% more catch. So the average yield increases, so this is good. The size structure rebuilds after a few years once you've put the size limit in place, and hence you get this increase in spawning biomass. Fantastic. This is great. You get more biomass. You get roughly similar average yields, even slightly more yields after the age structure is stabilized. But there's got to be something. You got to pay for something. What's the con here? Anybody guess? Why am I so against size limits? If I'm a fisherman who owns quota, why do I hate size limits? Price of the fish. What else? Yeah, you get some mortality from discards, but what's the roller man doing? About 6 or 7 times out of every 10 fish. You got to fish over twice as hard to catch the same amount of fish, right? Because most of the fish you're catching are below 82 centimeters. You're burning fuel and bait to catch them, and then you throw them overboard. So you got to fish roughly twice as hard to catch 5% more fish with an 82 centimeter size limit. So the price you're paying for conservation is you're burning fuel and bait. Cool. Somebody's got to pay for it. Okay. The message is when you put a size limit in place, you got to fish a lot harder or smarter. Go to an area where there aren't small fish, and you can catch the same amount of fish by weight. All right. Peggy's favorite question. We'll call this the Peggy procedure. What about protecting the big fish? I've heard a lot of people ask me this question. Shouldn't we protect the big old spawning females? So I just arbitrarily, I did this morning, threw in a slot limit where you're allowed to retain in the fishery anything that's greater than or equal to 82 centimeters, and anything that's greater than 108 centimeters you have to release carefully and put it back in the water. And again, there's a discard mortality rate of 15% on both sub-legal and large females or large halibut. And so here management procedure 2 was with the same one you saw before. We're looking at spawning biomass here. And management procedure 3, which is shown in teal now, is the slot limit. And the discard mortality rate is 15%. And what you see in these results is that you actually get less spawning biomass in the population when you protect those big old females. Does that make sense? Why does it make sense? One says you're killing more fish. That's right. You have to be killing more fish if there's killing smaller fish. But you're killing smaller fish in both policies. Everybody agree with that? You're killing bigger fish and smaller fish. The point is you're actually fishing harder to get the same amount of fish. You can either go fish 1 hook and catch 100 pounder, or you can go fish 5 hooks and catch 5 20 pounders. So that's your choice. You either have to go throw away a big fish that's equal to 5 smaller fish, and if you get the same price per pound, what's the difference? But seeing as how you're getting 25 cents more per pound for slightly bigger fish, you're still wasting a lot more fish, or it's still costing you money to go fish. So these are some of the sort of counterintuitive things that I remember having to do this a few years ago with Victoria O'Connell at the bycatch meeting. She couldn't understand how the heck could you get more spawning biomass or less spawning biomass when you put a size limit in. She was convinced that if we put in a size limit and protected fish, you'd end up with more spawning biomass, and that's not the point. Bruce.
Steve, there's one thing that comes up fairly often is that what's the fecundity of a very big old halibut relative to a mature female that is still fairly young? I mean, what's the fecundity issue about keeping these old girls in the water instead of harvesting them?
Okay, I'll put that on a to-do list and show you tomorrow. We call those maternal effects. That's been looked at a lot, but I can do that quite easy.
Yeah, well, I guess that's the general concept. I guess you can wait till tomorrow. I'll wait till tomorrow for that.
Yeah.
But you know, that's been an argument that's been come up about why you should release all fish over X amount of size. And I believe that, at least from what I understand, the data doesn't necessarily support that.
Yeah. So Sean Cox looked at this exact same question for sablefish, and they quickly threw it out. It didn't even get into the papers. It was so boring, the results. The message is you're better off keeping that fish because a fish that got that big, it may produce 10,000 times more eggs than the fish that didn't get that big. But the problem is the fish that are sexually mature, they're 50,000 times more abundant than the fish that got that big. So that's the trade-off you're looking at. Numerically, there's more fish who are teenage pregnancies than there are menopausal women having babies.
The other part of that is just it's recruitment isn't just the number of eggs that are put out there.
Yep.
It's full of all kinds of other factors that influence it. So if it was just the number of eggs, that'd be a much simpler kind of argument, but it's not. There's other things involved with it, and that's simply what we see in halibut. For most cases, there's a very strong environmental component into what makes a successful year class.
Yeah.
Oops, right. So that's okay for that objective of you're assuming you're protecting biomass, but what if the objective of the slot limit was to reduce your overall weight of your overall catch in a fishery to keep you on the water longer, so i.e. reduce your, so in the rec fishery they start introducing slot limits to increase or maintain their fishing season. I don't say you've done that, but I think that would be interesting to see because it seems to be a management procedure that is getting more and more traction.
Yeah, well, there's an objective we haven't even talked about is having opportunity throughout the year to access those fish when you're, say, in a recreational or guided fishery. We could certainly sit down and address those issues, but we haven't addressed those issues. Yeah. Yep. No, I agree. They do that in a lot of recreational fisheries in Florida. Snook, for example, is one of the species. They have a sort of slot limit, and they put it in place for exactly that reason, is to sort of maintain access to the resource throughout the year. Most snook are usually caught in the first 3 days of the opening, and then the whole fishery's dead.
I mean, that's essentially what the slot limit in Alaska
Yeah.
GC is about.
Yeah. Sure.
If we identified the size female that is the most fecund and set a slot limit, used a management tool of a slot limit to protect that age group, would we have the same results?
So if you were to identify the female that's most fecund, that's the largest female, or are you talking about set a size limit where the product of survivorship and fecundity is maximized? Yeah, if you set a slot limit on that perspective, then you would probably see a difference. Yep. But again, you would see probably a tenfold increase in the effort required to catch the same quota. So it comes at a price. Yep.
Steve, I was wondering too, with throwing away larger fish, I mean, their natural mortality rate would be higher, I would think, for a very large fish. So you're losing a lot of production, throwing away a fish that has a great chance of dying in the next couple of years for very large fish.
Yeah. We assume in this simulation here, we're assuming that the natural mortality rate is independent of size or age. They're just all constant. But you can certainly explore hypotheses. Ian may have started doing this a little bit in the assessment model, where you can have differential mortality rates for different sizes or ages in the model. And senescence is one that a lot of people come up with, was that these old fish, as they get out there, they basically, they're like grandmother. They're not going to live forever. And that probably does happen. What's hard to measure is that natural mortality rate. You're basically speculating out there. Ian, you looked at it for the smaller size classes?
Yeah, I haven't looked at any senescence hypotheses. The problem with senescence for most fish species is that it's very hard to distinguish between fish that get less catchable, maybe because they're moving into different areas or because they're just not very abundant as they get really, really, really old, versus actually dying off at a higher rate. And I don't think there's much conclusive evidence across any fish species for true senescence, the way we might see in people, for example.
It's also been not done on purpose, but accidentally been used to create electronic fish. We call it cryptic biomass. It's sort of this, it's either dome-shaped mortality. There's a bunch of fish out there, we just can't catch them. They're so big and old, and so we call those that cryptic biomass. Or people, for the same data set, will say, no, it's actually an asymptotic selectivity curve, but they just die off faster at older ages. And those are the two approaches that deal with the age composition data we see out there.
If you're going to have a slot limit, I think it'd behoove you, as while you're doing it. Recreational, you have a bag limit, so you can take one fish. Whereas if you have a poundage limit, you're going to catch 3 small ones equivalent to one size one. So, recreational does it like they do it in trout down south, in sea trout. You can catch 1 over 20. Or sturgeon, they do it where you can, keep between 47 and 60, but you're going to get 1 fish. It's not like you're going to keep catching until you get your weight, which commercially do. So it's, it's going to have a different result, depends on what your purpose of your fishing is.
Anyways, lots of discussions, or it's amazing how just one little simple thing can all of a sudden even gets my brain going on this, and I usually anticipate what the results are going to be. And often I'm wrong, which always surprises me, and I always think, something wrong with the model, and you go through it. The to-do list, just to give you a sort of an impression, along with the earlier figure I showed you with the plus symbols and minus symbols, we certainly have a lot of work to do on finishing this apartment building we're putting together, if you like. So continuing to develop and test this operating model and generating the various data structures that we anticipate we'll be able to put together here at the Halibut Commission. We still need to find ways of implementing migration and recruitment advection for spatially explicit models. We've got a colleague at UBC, Tom Carruthers, who's done some very interesting work using some old models that John Caddy developed in trying to estimate these things without tagging data. And then it turns out if you have tagging data to supplement that, you can do a much better job at estimating migration rates. And this is all being done with the bluefin tuna in IATCC, Lori Kell and folks over there. So we've been working with the Tuna Commission, or I've been working with the Tuna Commission folks to develop ways we can try and estimate migration kernels for different sizes or ages of halibut inside of our stock assessment models. There's a lot of work and research that needs to be done in that area, but nonetheless, we still have the infrastructure to put that there. Develop some more simple spatially explicit cases. I think these small exercise models that we do in this group, the last meeting and this meeting, are sophisticated enough it kind of makes you go, and scratch your head. I think if we were to reconvene and we had this all done, it may take me years, and certainly if it takes me that long, it's going to take everyone that long to try and digest and comprehend how this thing's going to all unfold. So I think it's very important that we develop simple structures, simple spatially explicit cases, so we can start to understand the implications of downstream effects of migration, et cetera, on various performance metrics that we're calculating. It will also help us clarify, I think, the objectives and the performance measures we need to develop in this MSC process. Questions? No. Modify the MSY-based, should be MSY, not May-based, reference points algorithms to explicitly account for size limits and bycatch caps. When we developed this stuff for the BC herring fishery, we didn't have size limits in the herring fishery, and we also don't have bycatch caps in the herring fishery in British Columbia. So this is some, again, I'll probably have to go spend a couple of months on the beach in Maui and do some more recreational mathematics to figure this problem out. It's a very technically challenging problem. I tried it at Starbucks yesterday. It didn't go so well. I think I need more caffeine. Fit the coastwide model to iSCAM and the available data. Again, as our spatial data structures come online, we'll be jointly fitting this same model to the spatially resolved data, and then trying to integrate the ability to estimate migration kernels, etc. Implement coastwide management strategy evaluation and explore performance of current management procedures versus perfect information. I think everybody wants to know this. It's called an open loop optimization problem. We can actually, right now, Robin's done this as class exercises. We can actually right now evaluate how well we're doing relative to a system where we happen to know perfect information. So it's kind of like doing retrospective analysis, where you assume that, okay, that is the recruitment history we would get. If you had to redo this fishery again in the future, how well does our current rules perform? Are we achieving 60% of our total yields, 80% of our total yields, or 95% of our total yields? I did this exercise for salmon fisheries in Alaska and the Fraser River sockeye salmon, and was found that we were able to achieve about 85% of the maximum yield in the Fraser River stocks, and we did about 90-something% in the Alaska Bristol Bay salmon stocks, making those assumptions. So it's a way to give ourselves a report card on how well we're doing in terms of exploring our management procedures. Yes?
Could you explain again what perfect information is?
Well, we have a computer here, and it's simulating population dynamics. So imagine we had a program here that could anticipate, and we knew exactly what recruitment was going to be in 2020, in 2021, and 2022. We would be able to, if we knew that the stock was going to collapse in 2025, we would probably say, well, it's going to collapse anyways, let's just go harvest them all. And if we knew recruitment was going to be good in 2030, we'd probably say, hey, let's hold back in 2026 and through 2029 and let the stock build up so it could get to a point where it would produce the maximum surplus. So this is called open loop optimization. And what you do is you basically score how well your rules that you currently use in the system would perform had you had perfect information.
So the perfect information is pretend perfect information.
Well, it's pretend
I can see what we do with it, but
it's pretend on our history of knowledge. So what I would do is I would start them all in 1923, and I'll say we're all going to go travel back in time in 1923, but with us we have the knowledge of what's going to happen to halibut resources over the next 100 years.
even though we don't have as much information from 1923 as we do today.
Yeah.
You just call it perfect
Yeah.
because it's what we have and what we know. Okay.
You make the assumption that it's perfect. So it's used a lot in systems control theory. The best example I can come up with, and it's a stupid one, but it's when people are trying to design algorithms for like mining equipment for crushing rocks, they'd have a computer standing there, and then they'd have a person on the control belt, and the person always won. And they were trying to figure out what is it the person knew that the computer couldn't figure out. So the computer's standing there staring at the size of rocks and then would adjust the machine to speed up or slow down depending on the size of the rocks. But what the person was doing was he was looking down the line to see what was coming. So he knew good recruitment was coming, so he knew to speed up the machine, or he knew to slow down the machine if there was, something bad was about to happen. That's what open loop optimization is, and it's really a way, another tool we can use without having to do management strategy evaluation to evaluate alternative rules. And a lot of people don't do that. We've published a few papers on it. It makes a lot of assumptions, but the place it originated was here at the Halibut Commission with some papers by Anna Parma and Carl Walters, and it's never been repeated since. But those seminal papers on the subject are largely why we have fixed harvest rate rules instead of fixed escapement rules in a lot of our salmon populations in Bristol Bay, but not in Fraser River.
I'm sorry, I don't want to, just one last thing, because I don't quite understand. This is what I don't understand. If we are putting ourselves back to 1923 and trying to apply certain conditions and decisions that we made and the result of management procedures that we put in place, how would that, things are different now, so how would that be applied? Can you give me an example of how it would be applied to help us know anything about which management procedures to use in the MSC process?
Sure. Seen that movie Back to the Future?
Yes.
Okay. I'm going to go to Ian's office. He's going to give me the recruitment time series from 1920 to 2014. Then I'm going to go jump in my, what kind of car? The DeLorean. Oh, yeah. I'm going to jump in my DeLorean. I'm going to go back to 1923. And I'm going to set up a fishery with my buddy Jeff Kaufman over there. And we're going to sit there and say, hey, we know that there's going to be some really bad recruitment over this decade, so let's let the spawning stock build up before that big poor recruitment event comes in, and we'll get the biomass at their peak of abundance and yield, and then we'll harvest them all, and then we'll sit on the fish and just harvest a little bit for a few years while the stock abundance is low, and when the next big recruitment event is going to come online, we'll back up a little bit so we can let the spawning stock biomass build up. So we can find a way to actually maximize over 100 years the total sum of the catch, or better yet, maximize the log of the catch. The reason I say the log is that we would place a high negative penalty on closing the fishery. So the log of 0 is a negative number, very, very big negative number. So we would close the fishery. Well, then I would take the results. I'm back in 2014. I take the results of what would happen, and I'll just plot catch versus biomass. And I'll ask, is there a simple rule, like a fixed exploitation rate rule or a fixed escapement rule or a 30-20 rule or a 40-10 rule that approximates a perfect world? I can send you some papers on salmon where we've done this. Yeah. So that's what we're trying to do. And the other question you can ask is, and we did this for the salmon fisheries, is that had we known now, or had we known back then what we knew now, how much more money could we have made off Fraser River sockeye? And we calculated that number was about $300 million. We could have made an additional $300 million on the fishery had we known back then what we knew now. And then we actually did the exercise of, okay, if we just use the techniques we have now and apply it to the data we had back then, how much more money can we make? It was about $100 million because there's still uncertainty. But the point is that we're learning from history. And what we're doing in this MSC process is we're sort of conditioning the model on history, but next year Ian's going to find another bug in the code, and then the model's going to change and history's wrong. So that's what we're trying to do is just sort of tackle this from another perspective. It's just an idea to throw out there. explore alternative harvest control rules. We've gone through a lot of that in the previous method. We have a lot of work to do, mostly Ian, who's really good at dealing with data and thinking about the data we've collected here at the Halibut Commission, setting up these spatially resolved data sets by regulatory area and reaching back as far as we can on the database has been a tremendous task, and I think we still have some time before that will be available to us. One of the things I want to talk a little bit about, I believe I missed, is focus a little bit on some of the performance measures and how we're going to relate these to the stated objectives. We kind of casually brought up the performance measures in a previous slide, but I want to talk briefly about the simple size limit example that we use. Highlights some of the counterintuitive results. The one is handling fish and careful release practices are really, really important. Those results you saw go away if the discard mortality rate is 0, because those fish will still be in the water theoretically to catch. You still have to fish harder to catch them, but a lot of the differences in biomass don't really change. There's a term I'll come up here with, is called fisheries efficiency, and what it really is it's the ratio of the catch we land, the legal fish, versus the total catch, which is the catch of sublegal plus legal fish. So this is right now in the two scenarios I just showed you, only about 45% of the fish we catch we actually retain. And Ian, what's the numbers coastwide? 6 out of 10 or no 4?
It varies by regulatory area, but the sublegal ratio by number ranges from somewhere in the 40% range up to close to 70%.
Yeah, so 7 out of 10 fish caught in this fishery right now in the directed fishery back over the side. And in 15% of those or 16% of those we assume will die, and then the remainder we hope they'll grow to a legal size when we get back. So is there a way, or are there tools where we can improve the efficiency and show the rest of the other user groups that we're good stewards of the resource? And I think those are some points you want to think about in developing this process. So just one second, Bruce, I'm almost finished. There are already economic incentives to do this, just spending less money on gear and bait and fishing in areas where there's bigger fish. But there's got to be other incentives that we can use and think about that. And I think there is, and we've certainly seen other examples in the British Columbia fishery. As soon as they went to their integrated fisheries and management programs, one of the things that happened right away is all of their quotas went up, because what used to be thrown away as discards were now legally allowed to be retained and sold in the fishery. So they all got about a 2 to 12% increase in their quotas overnight, just because what they used to have to throw overboard they now get to keep. So you got to think about carrots or incentives to think about how can we do a better job at this. What performance metric would we use to sort of capture fisheries efficiency? Right now we don't measure this in the field. We don't have the size composition data captured by fish in the commercial fishery, with the exception of Area 2B. So how should we integrate the prohibited species caps into the MSC process is another thing we've already had a discussion about. As Dan talked about, we need to also account for the total mortality and think about the accountability and the management of those resources. So I'll throw those out on the table as sort of discussion points and take questions from there. Thank you.
Yeah, it's Bruce Gabrus, 3A. Just maybe my math wasn't keeping up. Ian was saying that they're like 40-some%, and you just said 7 out of 10 get thrown back. So if we catch 10 fish, how many, and I'm assuming that you're talking about halibut now. So how many of those are sublegals or are thrown back? If you got 10 fish.
Ian?
So as Steve mentioned, we don't have a direct estimate of this. We don't actually have the observer data that's being collected, except in 2B, where we have logbook records that actually have the piece counts. What we use currently to estimate this is what we see on our set line survey, and in fact, that actually compares quite well in 2B to what's being reported in the logbooks. But the numbers, the specific numbers, and I don't have the table in front of me here, but it varies quite a bit by regulatory area. In 2B, recently, the estimates of sublegal to legal are in the range of 40 to 45%, I believe. So that's about 4 to 5 fish out of 10 are sublegal. In some other areas, particularly in the Western Gulf, I believe 3B and 4A are some of the higher estimates. Those estimates are above 60%. In some cases, I think more like 65%. So in the order of 6 to 7 fish out of 10 are sublegal.
Thank you.
I have kind of a general question that concerns me about models. When you use past historical information to build models, kind of predict future events, or how do you determine which parameters are causative and which may just be coincident correlations? For example, we wonder, why are the halibut so much smaller now? Maybe it's, maybe it's because we've increased the hake and the pollock fishery over the 80s and 90s, and now the fish have to work a lot harder to get food. So, that's not, that maybe hasn't been modeled, but maybe that's the real cause, and it's not any physical parameter that we're assuming works, because if you put those presumed assumptions in, the models work. But maybe that isn't the cause at all. Maybe it's something else that's totally unrelated that we just don't even know about. And so how do you ever have certainty that, the parameters you're picking are the right ones?
The short answer is you don't. All those hypotheses may be equally valid, and you can, without doing either a direct manipulative experiment, and even then that experiment would be subject to many assumptions, etc. You're basically doing correlations, is what it comes down to. We've gotten fairly decent at dealing with multivariate problems, so we may be able to look at this from the joint effects of fishing and density-dependent growth and competition with other species, and then trying to ask how much of the variance is explained by including these separate factors. I think the whole point about the MSC process is that we recognize that we're never going to get any of those right. And that's what the idea of having scenarios is that if you put all of these, say, 3 different scenarios that represent those hypotheses about size and age into your suite, the question is not which one's right, or how do you know which parameters are right or which parameters are wrong. It's the question is, which procedure would we pick is the most robust to all 3 of those hypotheses. And that's this process that we're engaging in.
Okay. Thanks, Steve. There's a lot in there, and it's probably there's a lot more in there than is necessarily apparent to everybody here in terms of the underpinnings and what was necessary to sort of build some of this stuff. I think the strong points on this are as Steve outlined them, in terms of being able to plug into the back end of a model. So when you make those changes, it carries right along with it, and you don't have to go through all this gnashing of teeth and late nights to sort of make the code keep up with changes in the model. That's very important. when we talked about this meeting and having a progress report, this was the primary vehicle that we're working on to try and help you with this. And Steve's outlined where we're going on this, and as you saw in his sort of status list, there's still quite a few blanks in there in terms of what we're capable of doing right now. But they've made really rapid progress in terms of actually putting this framework together. And it's, as I say, it's probably not quite as apparent to you how important some of this framework is as it is to other people working in this business. One of the scenarios that we want to look at first on this, aside from looking at the seismic stuff, was bycatch. And we're in the process of a couple of initiatives right now with bycatch, and I was going to ask Ian if you could just sort of outline, Ian, where we're sitting right now in terms of, we have a council initiative looking at PSC limits in the Bering Sea Aleutian Islands. We're preparing a paper for that for a presentation at the council meeting in June, as well as looking at a broader prospect of looking at sort of total mortality accounting. And Ian, I wonder if you could just go through that, please.
Yeah. So as Bruce mentioned, we do have quite a bit of ongoing work on this topic. We're first, for the June council meeting, we're preparing a report looking at both the status of the Bering Sea and Aleutian Islands halibut stock, as well as the effect of prohibited species catch or bycatch. And as part of that analysis, we're investigating the feedback of bycatch into the current harvest policy. This is going to be a little bit different than some of the previous analyses that were done that tried to estimate the lost yield and lost spawning biomass in an equilibrium context. In this case, we're looking more in a tactical sense at the direct effects on the way in which we're conducting the current harvest policy. So what do the apportionment tables look like, and what does the decision table look like when you make changes in the amount of bycatch that's being used for those tables? Then in preparation for the second piece that we're working on, which is the request from the commissioners at the annual meeting last year to investigate the management of total mortality from all sources and all sizes for halibut. We're extending this discussion a little bit to include the mortality of fish under 26 inches. So fish above 26 inches feed right into the apportionment tables, and it's sort of a one-for-one trade. It's very obvious in the calculations. But currently the U26 fish are basically off the books. They're not apparent in the apportionment tables. And so what we're doing is we're extending the framework for the current harvest policy so that we can account for those fish, so that we can track that, and we can look at, well, okay, if there's this degree of U26 mortality, how would you have to adjust the other harvest levels in order to maintain the same total harvest fishing intensity of all sizes on the stock? And how would that look in a set of apportionment tables? So this is an ongoing analysis. There'll be some preliminary results for this June report. But the important thing is not ultimately what's going to come of it, but it's providing a framework by which we can start to account for all these various sources and at least begin to see the trade-offs that are occurring. There are going to be some major uncertainties, and a main focus of both of these reports is going to be outlining which pieces of information we have and we can use right now to inform the discussion, and which pieces are highly uncertain and or we don't even know how to collect the data to do that. Some of the important components, as Steve already mentioned, is trying to understand more about how recruitment is distributed and how those fish move prior to their entry in the fishery, because I'd say the major impediment to accounting for and managing U26 or U32 halibut is understanding where the effects of those fish is going to occur. Unlike O26 fish, where we have the annual setline survey to apportion where we think the biomass that's associated with that removals is, we don't have an analogous index. We don't have an index that covers the whole distribution of the stock to tell us, well, where are these juvenile fish and in what abundance. So we'll be laying out the discussion around some of those sources. But that's kind of a quick overview of what we're up to. And it's quite relevant. Obviously, we've had a lot of questions here about it, and it's something that that Steve can evaluate a variety of different hypotheses in the MSE framework to get at questions that we may never have a clear answer to in terms of actual data about the halibut stock.
Thanks, Ian. Any questions on that, on what the objectives are for that? Okay. I guess what we're looking for here too is right now we've looked at well, we'll be looking at the objectives that we have in front of us, as well as trying to put into this the performance metrics that we've identified for this. I guess what we're also looking for is people's thoughts on alternative procedures to examine here. Things like catch limits, slot limits, timings, and so forth. So I'd like to open the floor up for that kind of discussion. Not everybody at once now.
I'm just curious if these presentations are available for us to look at tonight.
Yeah. Yes, we can
That'd
put
be
up
great.
on the SharePoint
Thank
site.
you.
Yeah. Everybody know how to get at your SharePoint site? Everybody remembers? Okay. Yeah. You have. I actually don't use it. You know, no, I get at it a different way. That's why. My
So on the MSAB, it's in Office 365, the SharePoint site that you all have at some point had access to. And if you have trouble getting to that, let me know, and then we can get you back in. But it's the place where we've posted everything from previous meetings. We also posted on the public side, but there's more detail on the inside, and that's where you can eventually you'll be doing some collaborative work with each other. So it's the one. It's Office 365, and you get into it via the internet, and you should have a login and a password for that all of you got from Jay Walker of our staff before the last meeting.
I may have to get an email with my password there on that, but I haven't been on for a while, but I think I remember it. I was going to say, though, regarding alternative procedures, or your example is size limit changes, and I know you just looked at that, Steve, with your shiny model there, but I know fishermen have never wanted to take off size limits, but we might have wanted to, change size limits just by a couple inches or by some small amount, such that, we're not going to maybe have the effects you saw there, and yet we're going to be running less gear, less fuel, less bait to catch our quotas. And we think it might be appropriate with this reduced size at age. So I'm not sure if that model will show up much with a 2 or 3 inch or several centimeter change.
Yeah, I can probably have that up on the screen for you in about 5-10 minutes. But my intention of showing this presentation was the extremes, just a fishery with no size limit, just to demonstrate with whatever current selectivity we have out there. And by the way, for the commercial fishery, selectivity below 32 inches, we're simply making the assumption that it's the same as what we see in the set line fishery, because that's the only place we have data on fish that we catch below that size. There's all kinds of other things that could happen. You could change the size limit, or the processors could change the price structure such that you get such a poor price for 1020s that you would go find a better place to fish anyways. There's all kinds of ways you can deal with this issue. This is just a sort of mandatory thing that's pretty easy to implement and show you. But yeah, I can show you just a couple inch change.
Could I just expand a little bit? What I would encourage you to do when you're thinking about something like that is to first put your objective forward on that. So when you're talking about changing it by a couple of inches, well, in order to do what? Are you trying to maximize your yield? You're trying to sort of minimize your fuel loss? It's sort of the net economic thing. So maybe try to think of it in those terms so that we can actually cast it in terms of an objective, so then we can talk about what the metrics are that you actually, how you address that objective.
And it's Bruce Gabris. I'm trying to remember the year, but we changed the size limit to 32 in 70-something.
Yeah.
And do we have any historical record of why we changed the size limit before we get into a big discussion? There's probably some wisdom in the discussion that raised the size limit the first time.
Ian, I think you looked at this when you were doing the data reconstruction, didn't you? Do you want to touch on that?
Yeah, it was 73 to 74 was the shift to the current size limit. There was actually a previous size limit. There was a 5-pound size limit initially, and then in the 1940s that was changed to a 22-inch minimum size limit, which then in the 70s switched to the current 32-inch minimum size limit. I actually don't remember off the top of my head specifically what the rationale was for that change in the 70s, but I can look that up and give you guys a little more.
If I'm not
on that.
mistaken, that was a straight yield per recruit calculation that they did at the time to try to optimize yield per recruit by that size limit.
Well, I'm sorry. This one, if it's in the 70s, that was a really horrible time in the fishery as far as that. So I imagine everybody was coming up with any kind of excuse they could to say, look, we got to do something to try to fix this fishery. And just the final note on that size limit discussion all the time, there also has to, I think, be a market component and a yield component of that, because them fish under 32, maybe 28 or 30 is not so bad, but the yield off that carcass is pretty darn light. Looks more like a tilapia, I think, when we get down to that size.
This gets back to the idea of looking at the objectives to begin with. So Brad's got a different objective with size limit than you might have in terms of numbers of fish you're going to be handling and his return on processing costs.
I have a question, a general question, and then a specific question. So on the general question, what data are available to be examined through the model?
Simulated data or real halibut fishery data?
Real data, both fishery and fishery independent.
Well, all of that stuff we have available on the IPHC website, but if there's other things, I don't know what the question is, but we have all of it. It's just a question of what scale do you want it at, what time frame do you want it at. Our data sharing agreements. What other things do we have? Yeah.
Okay, so I just wasn't sure if there was a list of data sources, and if you had access to logbook data, for example, not in the directed fishery, but or observer data by area, or if that varies by area. So just wanted to know what the various data sources you had available that you could use in the model. But a specific question, and this came up actually, Ian, when you were talking about the O26, U26, and I wasn't quite sure why we wouldn't have survey data that could help inform the U26, O26. So is there just not much U26 being caught in the survey?
Yeah, that's exactly correct. So both the fishery and the setline survey, because they're conducted with 16.0 circle hooks, don't encounter a high frequency of those fish. We do see those fish captured in trawl surveys. It's both the gear and the spatial distribution. So the smaller fish, especially the 1-year-olds, tend to be in much more nearshore waters, out away from where the adult biomass is. We do see those fish in trawl surveys, and we do have some estimates from those surveys, but they're not comprehensive across the whole range in every calendar year. So putting them together into an estimate of abundance is a little more problematic. I do have a quick follow-up. I found the reference to the minimum size limit, and it is specifically talking about yield, and basically the thinking at the time was that growth rates for the smaller fish are going to be high enough that leaving them in the water is a good idea, which is the yield per recruit argument. They're still growing at a much faster rate than they're dying. And it does explicitly say in here that the expectation is that there needs to be careful handling of these fish to avoid killing them. And in fact, one of the specific concerns is troll-caught halibut, which I guess were an issue in the 70s with the large number of salmon fisheries going on. But the expectation was that those fish, because they're handled on a fish-by-fish basis, would have quite a high survival rate. And so this would be sort of a benefit, because those fish, which had not yet reached peak yield per recruit, could be released with high survival rates. And then there's a secondary mention that perhaps the directed fishery would move away from areas with high encounter rates of these small fish as a function of that. I can post the original reference from 1973 introducing that to the MSAB site later, or get Jay to do it.
Sorry, so just the specific question, just thinking about other performance measures and what tools may be available. So what may be available in terms of spatial data? So if we were to look at areas to avoid, for example, is there information that could be available either from surveys, either trawl surveys or the IPHC survey, or even fishery data that could give you some sense of a spatial temporal distribution of halibut at different sizes?
Yeah, you bring up two interesting points. One, we have the contemporary data that we do have is even down to individual otoliths in our collection. We actually have the lat and long where that otolith came from, so it's highly resolved spatially. We also have a pretty comprehensive logbook program, and we cover a large fraction of the directed fishery. And Ian can elaborate more on some of the things we're starting to do with that. I'll speak specifically to what we're trying to do with the MSE and our assessments. Is we really are trying to address first at a course scale, so probably dealing with Area 2, Area 3, Area 4A, C, D, E, and then Area 4B is a separate area all on its own. So I have a four-area model to sort of take our first cut at some of the spatial issues. As we cut that area up into smaller and smaller pieces, the information requirements to estimate migration rates between those smaller statistical areas or regulatory areas becomes more intensive and takes a lot longer computationally, and we may get there, but we may find it's not even worth doing that exercise. But I think there's some real value in displaying the higher resolution stuff that we do have that we just haven't had time or the capability to display until more recently, and Ian can fill you in on some of the projects we're doing on that.
Before we leave that, I want to make sure there's a clear understanding here about what these tools are capable of doing versus what we have for data. So we have data that's much more highly resolved than we currently have the tools available to examine those with. That's the longer term goal of the spatially explicit operating model and we can use for that kind of investigation through the MSC. We're not there yet. So I want to condition people's expectations that, that's what we said to you early on in this process, is that, we're probably anywhere from 8 months to a year away from having that level of understanding and ability to do within this kind of process. Ian, did you have any comments you want to make on that?
I guess just that starting to partition these data sets out in a to a spatial resolution is a big challenge. It's going to take a while. I'm starting down that road, but we're going to be hampered both on the assessment side and the MSE side in our ability to cut these data sets up. It's fairly straightforward for some of the more recent data, but the farther we get back into history, the more difficult it is, and we'd rather do it right and work our way through it than do it multiple times. But nonetheless, as Steve pointed out, we're also going to be tackling this in increasing levels of complexity. So starting with an approach that divides the stock up into a small number of areas, perhaps just 2, 3, 4, and maybe 4B on its own, and investigating that. And there will certainly be a point where for the assessment analysis, I won't be able to proceed any further because the data are just not clear enough to provide a robust assessment model. And that's where the MSE process really begins to shine, because Steve can continue on down that path, and though the uncertainty then becomes different scenarios about how those dynamics might actually work, where we don't actually have data to tell us the specifics about migration of juveniles among smaller areas. But again, coming up with those hypotheses is going to be, I think, quite a challenge. I don't know if anybody's on the MSAB website, but I think I just put the PDF for the minimum size limit announcement that the IPHC issued up there, so somebody could check that, and if they can't see it, it is there? Yeah, good. I put it right in the documents on the MSAB SharePoint site. So it should be there available. If you can't see it, you can send me an email or someone else, and I can just send you the document specifically.
Oh, thanks. So this is some of the Canadian contingent. We've been talking about some of these things for a number of years, but also just recently, and some of them have been touched on. And understanding what Ian just talked about just a couple minutes ago about, accounting for fishing mortality of U26 in different areas and where that impact is. The thing that we've brought up a number of years is accounting by area for fishing mortality within that area, and I think there's two maybe ways of looking at it. Is where's that juvenile going to be, and try to account for what the loss might be there, or what would this more simplistic thing is say you have X number of total mortalities, how you convert that, and what that would look like to whether it be area removals or whatever, but seeing something a little more than what we've seen in the past, but what that may look like for either TACs or if you add in some migration, what the impacts are downstream to those areas. We talked about size limits. There's a number of combinations there. Within that, same thing about U26 is what are some management procedures to mitigate some of those bycatch impacts to different areas, what they may be. We've talked about use of the concept of sort of national shares to determine catch limits. So how would that even work, and what are some of the options that you may have to have? And so instead of looking at an apportionment is on a sort of mechanistic type of modeling exercise, what if there was an agreement to similar in whether that's totally appropriate, but what could it look like? So exploring those type of things, and what would national shares and what would have to be done, and then is that even realistic? But that type of process. And then we've talked about using the existing sort of management procedures we have now, 30% of spawning biomass, 20. Well, maybe change those control points up, and after you've done what's being done now, change those control points. What would that look like? Different reference removal rate. So we talked about this different harvest rates by area, but more specifically, what would they look like either by the different management areas or different regulatory areas, but having these different removal rates and different sort of type of harvest strategies. So, and of course the overall thing is how do you do it by, by area, which is what we'd really like to see, but maybe start as overall with what the journal stock would look like and what that would just under existing assumptions, how that would move. It does open up a lot of possibilities, and obviously this, whether that can be done or the time, like you've said, takes a long time, but it'd be nice sort of start going down these roads. And I had a couple other things to talk about, but they were more like scenarios. I'll just leave it at that for now.
Okay. Thanks, Jim. When you're talking about, make sure I understood this correctly, when you're talking about using the existing harvest policy as basically a jumping off point, so looking at different reference points and different control rules, is that
Yeah, and then you start to vary them up, right? So do what we talked about, we said it last time, I mean, I think it was said right at the beginning this meeting is evaluating the existing policies we have right now, harvest policies, and see how they're meeting things, and then varying those up.
I think the existing harvest policy has been through an evaluation, but it hasn't been done in a dynamic sense like this one has here, and that's where the advantage of it is. And
This may be my naivety, I'm not a modeler or an analyst, and when you talk about regional structure or area structure, when I was thinking about it, we have existing information about, we have different regional management procedures already in place, right? We have different time the fishery goes, we have different way we account for harvest removals, whether directed or bycatch. We have, and so we have, in 4A it starts later because of, just weather and other issues. In 2A it starts later for other issues. We have common kind of fisheries timing in the middle, but with different proportions of removals at different times. I mean, to me, we have existing regional structure already that we have information for, and whether or not that can be used to sort of start looking at, if you have these existing management procedures or these in different areas, what do you have? You sort of work backwards towards what type of removals overall do you have to get in different areas to sort of see what you're seeing? So get at the unaccounted for or the uncertainty in bycatch in certain areas by sort of working backwards. Whether that's actually.
So there's a couple issues in there. One of them is that I think it kind of presupposes some area-specific uniqueness there that you can evaluate impacts on an area-specific basis, perhaps.
Yeah,
but the other part of it is in trying to get any information from historical performance of these is how much contrast do we have in the application of those measures across multiple areas.
Yeah, but the interesting thing is we have, 1991 or 92, we had this dramatic fishery management procedure change in 2B, went to ITQs. 1995, we went to ITQs in Alaska. You had way different fisheries. They were short, high-intense, large bite fisheries, and then we've gone to this. So we have these contrasts. And I said, I don't know if you can actually do much with that, but it seems to me we have these different management procedures in time and space that seem to me maybe that's useful to look at. That we actually have information on what the fishery acted, what the data looked like.
It's a really good question. I mean, at this point, probably not, other than on a coastwide basis. And there you're trying. That's a fair leap from sort of an area-specific thing and what its impact might.
Well,
have been
maybe regional, right?
Thing, so, yeah.
Maybe not just so at regulatory area, but we may look at sort of broader areas and then just that approach.
Yeah. Okay. Thanks, Jim. That was useful to get some alternative procedures. Did you have something else? Sorry.
No.
Oh, okay. So this is kind of where we wanted to get to at the end of today, was having Steve go through this model procedure, let you guys think about this overnight a bit in terms of where we're going in terms of alternative procedures, and also have you think about the objectives as to whether we want to refine those, and we'll come back and revisit these tomorrow. But other thoughts from people before we break on this? Some things you might like to see us discuss tomorrow. We have a couple of governance issues we want to go through. Steve will have perhaps a little bit more information on one of these control rules to look at. Robin, yeah.
Thanks, Steve. It's great to see progress you've made so far. I just have I guess it's a question about the scope of the project and how much do we reasonably hope to achieve by the end of the project, which I guess will be 2015. And I'm thinking back to the annual meeting where there was a bycatch presentation, and in one of those slides there were a number of bycatch-related projects that were being suggested to be addressed by the by the MSAB process, including uncertainty and downstream impacts and mitigation of bycatch and those kinds of things. So I wonder if those are still on the table. And related to that, I'm just reading some old papers from the 80s by Rick DeRiso and others on different drivers of productivity for halibut, and they tested out a number of scenarios, including density dependence in growth, density dependence in mortality, purely climatic drivers of productivity and other things. So I just wonder how many scenarios would we be considering before this gets out of hand, I guess, because the impacts of undersized bycatch in that paper was really strongly influenced by what the underlying density-dependent process was. So I guess what I've been worrying about most in the last 6 months about this process is just its scope and just sort of reining it in so it stays focused and useful without missing some of the key points. Thanks.
That's a fantastic question, Robin, and I don't have an answer to it other than, one could easily say, well, I'll do it all, and then you have to realize that I have 3 kids back at home who want me to do something else. The reality of it is that I think we have to find, as Rob Cronlund says, a sort of absolute bare minimum that has to be satisfied, such that we can start to rule out a lot of the crazy ideas we might throw into the mix. I'll quote Rob Cronlund again, the combinatorics will kill you when you think of how many different scenarios, how many different procedures we can quickly come up with. Just in the last 5 minutes, I wrote down 3 different scenarios and 4 different procedures that you could quickly test, and we have to basically go through and satisfy that first high priority constraint. Any procedure that doesn't satisfy that, you just kind of have to drop it and say, we've looked at it, issues done and over. Regarding the scenario thing, I think everybody can get down to the nuts and bolts of non-stationarity. Is it density-dependent growth? Is it recruitment dynamics? Is it variation in natural mortality? The underlying problem is it's just non-stationarity, and it really doesn't matter what the source of it is. It's something we may not, or most likely will not, be able to manage. So what we have to perhaps do is just limit the scenarios over which we explore things that just simply addresses the non-stationarity issue. And that's really what we're talking about here, is halibut stocks go up and down. There's several hypotheses as to why they go up and why they go down. The point is that we probably can't control much of them, or if we can control them, some other agencies involved in them, and our hands are tied anyways. So let's just internally try and deal with the scope we can deal with. And you've put the picture frame around this problem exactly. I'll pose a question back to the group, because we're not the only game in town. There's a couple of other MSE-related projects for very similar fisheries. Actually, one of them you're involved in with the Pacific hake, and I think this group would probably benefit in our next meeting, perhaps seeing some presentations that are being done in the management strategy evaluation work for Pacific Hake, and then I'll talk to Felipe and see if he can come do the ones for the Pacific Sardine work that's being well. And the sardine is a classic non-stationarity problem where they just have, you know, sardines and then no sardines and then sardines and no sardines, and how are they trying to cope with that? And I think Felipe had thousands of permutations and combinations, and what he did have was some really neat graphics that you could throw the summary results from all kinds of things and see how procedures cluster together. And then on those graphs, you can just put these thresholds where you just say, okay, we're going to stop looking at all of these things, or we'll look at these outliers and find out why they work so well. So that's the way we have to do this thing, is just sort of identify what really matters. And it's not necessarily understanding the mechanism that causes size at age to change. It's just understanding that size at age does change, and how we cope with it is what our procedural problem is. Great question.
Yeah, thanks, Rowan and Steve on that. I mean, that's a very key point here, and one of the objectives for this group is to try actually not to expand this thing, but to winnow it down to the key things that we want to look at. And I think this process will become more efficient when you can start to work with the tools, so you can actually take a look at some of these things. And right now, we're not quite there yet. So. But I mean, your point is absolutely right, Robin, is that we can't afford to let this get out of hand. But I actually like very much your answer on this one, Steve, is that the non-stationarity is an issue that we're not necessarily going to be able to control, but we can put in as a scenario and then develop procedures that are robust to that non-stationarity. It's a big deal. So, Michelle, do you have something?
Just kind of a similar question, I guess, on the scope, and was just trying to think through what we may have available to us, understanding that in many cases we'll be looking to other entities that we'd be making recommendations to actually do the implementation or regulatory structure, but was just wondering on a comparison of management regulatory tools that may be available versus what we have the data to support. So when I think about fishery regulations, and so I asked the question about spatial data, and immediately folks jump to kind of migration, but actually I was thinking of area closures as a bycatch reduction measure. In the trawl fishery, for example, are there areas that tend to produce smaller halibut or larger halibut? And so are there some area closures that we might recommend even on a seasonal basis? So I'm trying to reconcile, I guess, again, the management regulatory tools we may have available in our toolbox versus what do we have the data to support being able to use those.
That's a really excellent point, Michelle, because at the end of the day, we have, like you said, we've got a set of toolboxes in our management toolbox, so what we can use. And yeah, I just, that really resonates with me in terms of, you know, what's in the art of the doable. When we go back to the data, again, we're going to come back to what are we capable of analyzing with this process? How well resolved can we make those investigations? And that's where we still got a ways to go. Okay.
They're all waiting to see the 30-inch size.
Yeah. So, anyway, tomorrow, the main things we want to get into are we want to talk a little bit about what potential impacts, if we have any changes in the stock assessment, how that might affect the MSC outline. We don't think there's necessarily a lot in here. I would like to go through a little bit, as I said, on governance of where this project is going, what the outputs of this are right in the short term as well as in the somewhat longer term. So I would like to talk about that. What else? There's one more. Oh, and also what your tasks are going to be for the next meeting. I said, anything else that anybody wants to talk about tomorrow? No. All right. Thank you for your attention today. I know this was kind of a long afternoon and kind of a heavy lifting getting through this thing, but we wanted to give you a fairly good understanding of not only where we are, but what we're sort of headed for in terms of the potential for this. But we have a ways to go on the operating model to make it a fully spatial model. So I'm sure everybody understands that. So, all right. Thank you very much. We'll see you tomorrow morning. We have coffee and pastries here at 8. We'll be actually sitting underway at 8:30. Is that what time we're getting? Where did Steve go? Did it for the hotel? Okay. Thank you.
You are the last party in the conference.